Хей, здравейте приятели, аз съм Айхани Фая, фотограф, видеограф и блогър. Сигурен съм и наистина предчувствам, че по този видеоклип ще има коментари от сорта на това не е възможно, приятелю. Приятелю, образовай се, приятелю, това няма как да стане, стига си говорил глупости. Всъщност, което е напълно нормално. Винаги има два типа хора. Хора, които вярват на такива истории и хора, които не вярват на такива истории, което всъщност е напълно нормално. Винаги има противоположности. Има да, има не, има ин, има ян, има топла вода, има студена вода. Как е било възможно да се появят подобни хора и да ни предскажат какво ни очаква в близките години или по-точно в бъдещето? Знаехте ли, че всъщност роботите в бъдеще ще управляват света? Знаехте ли, че масово във фирмите ще работят роботи и няма да има човешка ръка? Знаете ли, че всъщност роботите ще могат да вземат и да колонизират други планети? Когато разказвам за този видеоклип и когато говоря пред вас в момента, аз настрахвам. Понеже това, което ни очаква, от части ще ни облегчи, а от друга част не е чак толкова. Но все пак бих искал да чуя и вашето мнение, приятели. Видеоклипът съм го обработвал много внимателно, така че съм сигурен, че видеоклипът ще ви хареса. И преди да започнем видеоклипа, не забравяйте един лайк, един коментар и най-важното, приятели, и най-важното абониране с камбанка. Именно по този начин вие получавате уведомления, когато аз качвам нови видеоклипове в YouTube. А сега ви желая приятно гледане, приятели. Темата за пътуване във времето интересува не само нормалните хора, но и различните изследователи по цял свят. За цялата история на човечеството някои хора утвърждават, че са пребивавали в бъдещето, разказвайки разни събития, които ни предстои да преживеем или давайки объркващи описания и исторически факти. За последните няколко години в интернет пространството са се появили истории на хора, които разказват как са пътували във времето или са се оказали в миналото. От човекът, който ни е предсказал какво ни очаква в близките 10 години, до човекът, който е заседнал между два свята. Днес ще ви разкажа за хора, които са пътували във времето. Нека да започваме, приятели. Но има един канал, в който се качват клипове на тема пътуване във времето. Един от героите на канала е станал човек на име Ноа, който е проникнал в интернет през 2007 година, утвърждавайки, че той се явява пътешественик във времето от 2300 година, заседнал в наши дни. Много ютубъри са започнали да правят клипове с него и за всеки един канал той е казвал различни предсказания, описващи бъдещето. Той е споделил, че пътуването във времето ще е достъпно за обществеността от 2028 година. Също той е споделил, че технологиите за пътуване във времето вече са разработени и произведени, но за сега се пазят в тайна. От 2017 година са се появили много клипове в интернет, той е минала през детектора на лъжата, опитвайки се да докаже правдивостта на своите истории. Ноа е показал неща, които изглеждат сякаш докарани от бъдещето и разказва, че в близките 10-15 години всичко ще се промени. Сред тях можем да разграничим книгите и новата карта на Америка. Ноа е разказал много интересни факти за бъдещето на САЩ, Великобритания, Канада, Индия, Русия. Въпреки че е много трудно да повярвате в историята с Ноа, тя все пак заслужава внимание. Той е споделил, че до 2300 година изкуственият интелект ще овладее света, а криптовалутите ще станат основната валута. Именно за това той препоръчва да започнем да влагаме пари в тази сфера на бъдещето. Също така, по неговите думи, климатът на Северна Америка ще стане по-топъл и мек, а климатът на Европа по-студен. Също така, не гледайки на ниският рейтинг сред гражданите на Америка към Доналд Тръмп, той ще бъде отново преизбран, а след него президент ще стане млада 23 годишна жена. Той е утвърждавал, че не може да предостави доказателства заради феномена на парадокса. Във всеки случай, в отличие от други пътешественици във времето, той е споделил какво ни очаква. А и съвсем скоро ще узнаем достоверността на неговата информация и да разберем, явява ли се шарлатан или това е един от малкото случаи, в които ни предсказват бъдещето. Пол Динах. През 1921 година швейцарският учител с името Пол Динах е попаднал в кома за цяла година. Събуждайки се, той е започнал да пише някакви неща на своя дневник, но учителя на никой не е показвал своите записи. За първи път записите на Пол Динах са видяни от един от неговите ученици, който Пол го е помолил да направи превод. Ученикът е забелязал, че записите на Пол описват далечното бъдеще. Пол е утвърждавал, че когато той е бил в кома, той е пътувал до 3906 година и се е оказал в тялото на Ендри Нортман, който по неговите думи също е бил в кома, но вече в далечното бъдеще. Както казва учителя, по някакъв начин с Ендри са си сменили телата и учителя е започнал да изучава бъдещия свят. В своите записи той пише, че Марс ще се колонизира от хората примерно към 23 век, но един ден ще има ужасяващ катаклизъм, който ще сложи край на 20 милиона души. Също той е написал, че след 100 години след това на Земята ще се случи ужасна глобална война, която ще унищожи цели цивилизации и ще нанесе огромен удар на нашата планета. Краят на тази война ще бъде обявен от всемогъщото глобално правителство. През 3382 година ще е последният етап от еволюцията на хората и в света ще цари мир. Струва се да отбележа, че когато Пол е водил записи, той е писал много бързо и на моменти не се е разбирало нищо от написаното, което ни натяква на мисълта, че е вярвал в това, което е писал. Удивително е, че Пол не е искал да споделя записите с никой от своето обкръжение. Причината не е ясна, а ученикът е станало изключение. Записите са получили огромна популярност, когато ученикът го е превел и го е публикувал през 1972 година в Гърция с названието Хроники от бъдещето. Ако той не беше споделил тази история, света и до ден днешен нямаше да знае какво е преживял той. Отчитайки, че в дневника на Пол отсъства информация за 21 век, е сложно да се провери информацията, а на нас не остава да изчакаме това време, за да видим дали Пол е бил наистина прав и е предсказал нашето бъдеще. Ако това излезе истина и се окаже, че учителят е казал истината, то това ще стане истинска научна сензация. Уилям Тейлър. Британецът Уилям Тейлър първоначално той е утвърждавал, че от 2005 година се е преместил в 3000 година, а след това в 8973 година, след което се е върнал в наши дни. Той е утвърждавал, че е работил за британска разузнавателна агенция и са го изпратили в бъдеще за експеримента, който се е наричал пътуване във времето, над който експеримент агенцията е работила още от далечната 1981 година. Първоначално британецът е бил в 3000 година. По неговите думи, през тази година хората ще престанат да ходят и шофират по земята, а ще се предвижват с летателни апарати. Уилям твърди, че през тази година земята ще е населена от слаби хуманоиди с огромни глави. След това Уилям се е отправил в 8973 година. По негови думи, през тази година не съществуват болести, смъртност, войни и престъпност. По негови думи, след 70 столетия, Земята ще се управлява от високи, стройни човекоподобни роботи с големи глави и очи. Той е добавил, че тези киборги ще колонизират и други светове. Уилям е споделил, че в бъдеще, към темата пътуване във времето, хората ще се отнасят напълно нормално. Именно никой от тези роботи не се е удивил, когато той е казал, че е дошъл от миналото. Също е споделил, че е срещнал други пътешественици във времето от 2055 година. Освен това са били представени няколко сведения и проекти за британското правителство, които са били свързани с пътуване във времето. Той е казал, че вече през 2028 година на човечеството ще бъде представено и разкрито технология за специфичният летателен апарат. С неговата помощ хората ще могат не само да пътуват във времето, но и да ходят между паралелни вселени. Предсказанията изглеждат доста убеждаващи, така че за нас остава да изчакаме този период и да видим дали това ще стане реалност или не. Пелегрино Ернети. През 2002 година френски католик, свещеник и писател Франсуа Бруно е публикувал книга с названието Хронопроекционен апарат – новата тайна на Ватикана. В тази книга той е написал история за ватиканския монах и учена с име Пелегрино Ернети, който по думите на Бруно заедно с група изследователи е построил машина на времето с името хроновизор, устройство позволяващо да пътуваш в миналото, за да се видят исторически събития със своите очи. Хроновизора работи по принципа на третиране с остатъчно електромагнитно излъчване, съхранено от многочислени процеси от миналото. След обработката радиовълните на електромагнитното излъчване, хроновизора създава на тяхна основа събития от миналото и ги конвертира в настояще време. В такъв образ зрителите могат да изгледат минало събитие в настояще време. Както пише Брюн, Пелегрино няколко пъти е използвал хроновизора, за да стане свидетел на определени исторически събития. С помощта на свещеника Ернети е бил на опера Триест, който е създал истински фурор в Рим през 169 година преди новата ера. Също е станал свидетел за разпъването на Исус. Днес информация за хроновизора няма, а всичко каквото се продава в интернет с подобно название е фалшиво. Критиците и скептиците са уверени в това, че разказът на Франсуа е измислен или е силно преувеличен. Въпреки това много теоретици са уверени в обратното. Те вярват, че историята е реална. Също така и изобретението. Както знаете, в Ватикана има много скрита информация, която се крие от обществеността. Те считат, че такова изобретение като хроновизор съществува и членовете на католическата църква до ден днешен пътуват във времето с помощта на този апарат. Боб Уайт. През 2003 година на електронната поща на Дейв са дошли много интересни съобщения, които са били отбелязани като спам, но съществено са се отличавали от обичайните рекламни мейли. Авторът на тези съобщения е бил някакъв Боб Уайт, който е утвърждавал, че е пътешественик във времето, който в момента е в 2003 година. В своето съобщение Боб е предлагал да му помогне за създаването на кондензатор за преобразуване на времето с хибриден модул и генератор, също и индукционен двигател. Както се е оказало, този мейл не е бил получен само от един човек, а от много хора в САЩ. На тези хора, които са се съгласявали да му помогнат, се е предлагало възнаграждение от $5000. Дейв, заинтересуван от писмото, е решил да отговори на пътешественика във времето, казвайки, че е готов да предоставя цялото нужно оборудване. Според някои източници може да се разбере, че Дейв даже е изпратил пратка на Боб. Той си е мислил, че това е някаква томбола и че Боб би му отговорил със смешна пратка. Вместо това Боб е благодарил за предоставеното оборудване. Когато историята се е популяризирала в интернет, е станало ясно, че Боб Уайт всъщност е бил Робърт Дин. Както се е разбрало, е желаял да се отправи в бъдещето. Трудно е да се каже колко писма е изпратил и кой всъщност е бил той. Неговите спам съобщения са влезли в списъка с най-необичайните и оригинални писма за всички времена в интернет. Вече виждам и чувствам коментарите под видеоклипа. Чувствам, че хората вече пишат да отида на лекар или пък да се прегледам, или че това са фантазии, или че това не е реално, или че това няма как да стане. Приятели, всъщност съвсем нормално е да не вярвате на тези истории, понеже както съм споделял с вас и по-рано, има два типа хора. Има хора, които ще повярват на тези истории, има хора и които няма да повярват на тези истории. Разбира се, има хора, които вярват на конспиративни теории, има и такива хора, които не вярват на конспиративни теории. Винаги хората се делят на два типа. Така че е напълно нормално. Искам наистина да чуя вашето мнение долу в коментарите. Долу в коментарите споделете вашето искрено мнение. Аз бях Айхан Инфая. Благодаря ви за отделеното време. За този видеоклип съм отделил специално много време и исках този видеоклип да го обработя, да го направя специално за вас, приятели. Ако сте пропуснали първата част на хора, които са пътували във времето, то долу в коментарите и в описанието ще поставя линк към него. Той също е много интересен видеоклип и съм сигурен, че много ще ви хареса. И това беше всичко, приятели. Аз съм Айхан Инфая. Не забравяйте да се абонирате за моят канал с камбанка, защото съвсем скоро излизат страхотни видеоклипове, за които съм сигурен, че не сте ги очаквали въобще от български YouTube канал. Именно вие имате страхотната възможност да ги видите безплатно. Само срещу една камбанка. Чао, приятели, и до скоро!
Hello, wonderful person. This is Anton, and today we're going to be talking about a discovery of a very interesting star system somewhere out there. The star system that has 6 very unique planets with an extremely interesting pattern of orbit around the star. The pattern that we usually refer to as orbital resonance, but in this particular case the resonance is very unique, something that we've never seen before. And so let's discuss this discovery in a little bit more detail, but also talk about resonances in general. And let's start this with a bit of a history trip into early astronomy. Back in the days, here we're talking about hundreds of years ago, the early astronomers realized that there was actually a bit of a pattern to the placement of planets in the solar system. So here, for example, if we were to take a look at the distance of Mercury from the Sun and then multiply it by 2, we would roughly get the orbit of Venus. Then multiply this by roughly around 2, and you get the orbit of Earth. Then you get orbit of Mars, and then there's an unusual gap. And following this gap, you get the orbit of Jupiter, followed by the orbit of Saturn, and back in the days this is actually how Uranus was discovered as well. Because of this unusual prediction, scientists estimated that there was actually another planet somewhere out there. But this pattern obviously doesn't work with Neptune and with anything past Neptune. However, interestingly, because of this pattern, the scientists were also able to discover Ceres and a lot of other objects we refer to as asteroids in the asteroid belt. They initially thought that this was a missing planet, but we now understand that this is not a planet, and we also know that the asteroid belt might actually be a remnant from the early formation of the solar system, but because of the influences from Jupiter, it never really became a planet at all. Nevertheless, there is a strange pattern and a strange correlation with distances away from the Sun, and to some extent this can be maybe used to determine certain other patterns in other star systems. The one in the solar system actually has a name, and I made a video about this a few years ago. It's known as this law right here, and it is accurate to some extent, but obviously has a few exceptions that don't really make any sense, like the orbits of Neptune and of course the orbit of Pluto and other objects. But when it comes to orbital patterns, we know that there is something called orbital resonance, and the best example of this is right here in the solar system around Jupiter. The first 3 moons of Jupiter form an exact orbital pattern of 4, 2, and 1. In other words, for every 4 orbits of Io, Europa is going to make 2 orbits and Ganymede is going to make 1 orbit. And these orbital resonances have actually been detected in many different places and also do play a very important role in our understanding of the formation of various systems. Today we think that, or at least we believe that, they usually develop as the material orbiting something moves closer and closer to that object, and the material itself stabilizes the overall mass of all of these objects to form these patterns in order not to disrupt anything else in the system. In other words, this is a stable formation of an orbital system as it sort of reshuffles around some sort of a central object. And it's possible that this is exactly what happened in the solar system with these various patterns we're observing, but in this case, Jupiter, because of its sheer mass, is also able to disrupt certain patterns and actually does influence and change the solar system over a period of billions of years. But because we know these resonances exist and because we know they're very important for the stability of a system, discovering these patterns in other star systems, such as the famous TRAPPIST-1, helps us understand whether there are any other potential hidden objects in this particular system, and also helps us understand how these systems evolve. Now in TRAPPIST-1, the resonance is also there, but it's actually a lot more complex, with relatively complex ratios forming between the orbits of these planets. Although overall these ratios are extremely close to 1.5, which means that for every 3 orbits of the closer planet, the more distant planet is going to do 2 orbits. And this is a really important resonance because first of all it's extremely common, second of all it usually shows us that this particular star system is relatively stable, but because of the deviations in these patterns it also allows us to discover other massive objects. Which is why it's really important to analyze this particular system, located around 88 light years away from us, where 6 different planets form a very interesting and extremely precise orbital resonance that actually can help us explain a lot of things about the star system, but also help us understand how to analyze other star systems as well. So in this particular case, we have an interesting star very similar to our own Sun, where 6 planets seem to be orbiting extremely close to the star itself, with each of these planets being defined as a kind of a super Earth or some kind of a Neptune-like object, but in this case, really hot super Earth and really hot Neptune planets. Based on the masses and the sizes of these planets, the estimates so far suggest that about 5 of them are essentially these Neptune-like worlds, and possibly 1 is a super Earth, with the smallest planet being about 2.2 masses of planet Earth, and the largest one being more massive than Neptune itself. In other words, even though the star in the system is similar to the Sun, everything else here is extremely different from any other system we've observed so far. All of the planets here are really close to the star. The orbit of the closest planet here is only about 2.17 days long, and that makes this planet extremely hot, obviously. But what's interesting though is that if you were to multiply that value by 1.5, you would get the orbital period of the next planet. Do this again and you get the 3rd planet, and then the 4th planet, and then the 5th and the 6th. And that's where things become really interesting, because the orbital resonance of 3 to 2 applies to each of these 6 planets, with the last planet having an orbital period of about 17.5 days. Now that's obviously about 4 times closer to the star than Mercury is to the Sun, which makes each of these planets extremely hot, especially if they have thick atmospheres. But because of this unusual 3 to 2 resonance amongst all of the planets, it also obviously creates extremely stable system that's going to stay stable for possibly billions of years, until I guess these planets evaporate completely. And you can kind of see that even in this simulation their atmospheres are evaporating extremely fast, which also suggests that only the core of these planets is going to remain in the next few billions of years. But just like with the other resonances, this also means that a lot of these planets probably formed somewhere on the outskirts of the star system and slowly migrated toward the star, where they eventually settled on these very specific and very stable patterns. Today we believe that this usually happens as the planetary system where the planets develop interacts with the remnant of the gas in the disk itself, pictures of which we have from many different young star systems out there, like this one right here known as HL Tauri. And so as the planets migrate through the disk and as they essentially come closer and closer to the star because of the interaction with all of this dust here, they eventually stabilize in certain orbital patterns similar to the ones we observed in systems like TRAPPIST-1 and Kepler-80. But in this particular case, none of these resonances are perfect. In most cases, they have slight deviations from the usual 3 to 2 or 2 to 1 resonance. And this can be actually explained by all sorts of different instabilities introduced into the star system as all of this gas dissipates and the actual planetary system is born. And so because of these imperfections in the orbital resonance, we can actually use this to try to determine the initial mass of the protoplanetary disk from which this particular star system was born. And if we're able to do it for this particular star system, this in turn can help us analyze our own solar system and thus discover what the protoplanetary disk of the Sun looked like. In other words, it can help us see the history of the solar system if we can actually figure out how all of this works in other star systems as well. At the same time, these inaccuracies in resonance kind of point at various mass discrepancies and of course composition and mass of each of these planets. So in that way we can also use these patterns to try to analyze what all of these planets have on the inside. But all of this is of course in the future. For now, all we know is that this interesting star system, at least for now, seems to be the only system out there with the most perfect resonance of all of the objects out there, with the orbital resonance between each of the planets being almost exactly 1.5. So once again, for every 3 orbits of the closer planet, the farther planet is going to orbit twice. And because this applies to each of the 6 planets here, this actually makes this an extremely interesting star system to study and also an extremely valuable source in learning how star systems and of course solar system developed over time and progressed from being just a cloud to then being a disk with protoplanetary objects, to then eventually becoming a star system with planets in a very specific region. And because so far we only have a few star systems out there that we know of that have more than 5 planets in them, including TRAPPIST-1, Kepler-80, and now HD 158259, and every one of these planets seems to possess some sort of a resonance, it's also important for us to learn how these resonances influence planets in order for us to be able to discover other planets much easier. Which is, by the way, how one of the planets here was discovered to begin with. By looking at these patterns, the scientists realized that there was another object hiding in the data. And so once we figure out how these patterns work, and more specifically what type of a pattern to expect from a certain star, we might be able to find planets much easier and also much quicker. For now though, this is a very interesting discovery, definitely a star system that we kind of didn't expect to find, and also a star system that just seems extremely different from the solar system despite the similarity with the Sun. But until future studies, that's unfortunately all we know about the star system and about these resonances.
Нещо витае във въздуха. Случва се отново. Вълнението от предстоящите приключения, от усещането да шофираш уверено, от по-модерните технологии, от дизайна, който се забелязва. Градският кросовър се завръща и е готов да те отведе по-далеч. Новият Nissan Qashqai.
Hello wonderful person, this is Anton, and today we're going to try to answer a question of oxygen in some of the planets we might find in the future. So imagine for a second we discovered oxygen on this planet known as TRAPPIST-1b. What exactly does this mean? Does this mean we just found life? Is this oxygen created by some sort of a bacterial life? Or can this be what's known as a false positive? Can this be just a sign of some sort of a chemical reaction? Well, naturally the answer is yes, but what kind of a reaction and what exactly should we be looking for? And so that's pretty much what this particular paper wants to answer. They used several computer simulations to try to create various types of planets similar to planet Earth, orbiting a star similar to our own Sun, with very minor modifications of how many different types of volatiles or how many different types of gases are present in the early atmosphere. And then they try to discover if any of those planets can actually create conditions with a lot of oxygen that's not produced by life, that's produced naturally through geochemical reactions. And so interestingly, they've discovered at least 3 scenarios where it's possible, 3 false positives. And considering the fact that we've already discovered and confirmed over 4,000 exoplanets, the number that's going to become about 10,000 in a few years from now, and also considering the fact that new telescopes such as James Webb that's going to be released later this year are going to be really good at finding these molecules, it's super important for us to be able to identify all sorts of different molecules present in the atmosphere of those planets in order to establish the origin of those molecules. With the main emphasis of course being oxygen, because we know that oxygen on our planet is produced by life. And if we find a planet similar to Earth that has oxygen, does that mean life as well? And so the scientists in this paper argue against that because they do provide evidence for potential Earth-like planets to have oxygen with really no life whatsoever. But first of all, how would the oxygen be even produced in these conditions, especially when there's no life? Well, generally speaking, as long as you have a little bit of water somewhere in the atmosphere, maybe on the surface, and as long as there's something going on that can break down this water, which in this case usually means the presence of ultraviolet radiation coming from the star, the water will always break down into hydrogen molecules and oxygen molecules. With hydrogen escaping into the outer space because it's a much lighter gas, but oxygen very likely just sticking around for a while, and in some cases sticking around for several million years. Now in most cases though, it is going to be absorbed by something. So for example, let's just say we take this hypothetical Earth with very similar conditions to actual Earth a few billion years ago, and for a few billion years let it evolve. So it's going to have a lot of geochemical reactions, it's obviously going to cool down and so on, but unlike actual Earth, it's going to be a little bit different. In this case, this planet seems to have a lot less water than original Earth. It's kind of patchy in that sense. In this case, the scientists refer to this as the desert world. Now you might actually see this as something a little bit familiar. It does look like the model of that Mars that I've talked about in one of the previous videos, and that's exactly what the scientists imply here. A patchy desert world will actually have very similar conditions to early Earth and will even start producing oxygen as well through geochemical reactions. In this case, because there was a lot less water present on the surface, as the planet cools down from the initial magma stage, it's going to end up releasing a lot of this water as the atmospheric water. And as all of this atmospheric water accumulates, it ends up being broken down by the star, and this produces a lot of oxygen that very likely lingers in the atmosphere for a very long time. Now, eventually this oxygen starts being removed, usually through various geochemical reactions, for example through various volcanic activity that might release things like carbon monoxide and hydrogen, which might combine with oxygen, creating a little bit more water and a lot of carbon dioxide, while at the same time most likely also influencing the surface as well. All of this oxygen ends up weathering the surface, turning it somewhat red to what you see right here on the surface of Mars. So in other words, this is a very interesting model representing what might have been happening on Mars a few billion years ago. But in contrast, if you were to look at our own planet, once the water condenses on the surface, all of this water sort of remained here. The escape rates and the production of atmospheric water were much lower than they were on those other desert planets. And so those desert planets tend to produce a lot of atmospheric water, which then starts to break down into oxygen and remain in the atmosphere for up to about 1 million years. But remember, none of this is related to life at all. It's just a geochemical reaction. And so this is if you start with a little bit less water. But then you can have a condition where the planet starts with a lot more CO2 compared to everything else. This is a slightly different scenario because here you end up with an atmosphere that's much hotter than usual. And because of this greenhouse effect, which in this case the scientists refer to as the eternal runaway greenhouse effect, you end up with a planet where the atmosphere is predominantly carbon dioxide, but also has a little bit of water and starts forming a lot of oxygen as well. And all of this oxygen comes from the fact that any water that was present here could not create any liquid on the surface. The planet was just a little bit too hot. And so it all ends up being as atmospheric water, and because CO2 is a little bit heavier than H2O, H2O starts to move to the top of the surface of the atmosphere. And right there on the top, that's where the star once again starts to break it down into hydrogen and oxygen, and the same cycle repeats again. Although in this particular case, it's very likely that there are not going to be a lot of opportunities for this oxygen to become integrated into something else. It actually might remain as oxygen for even longer, maybe millions, maybe billions of years. And you might have guessed already, but this is exactly what we think might have happened to Venus. Venus, as you know, is extremely hot because of the presence of CO2. Venus also most likely had a little bit of water in the past. And today we know that Venus seems to lose a little bit of oxygen from the surface. This oxygen could be coming from the water that's still somewhere on Venus. And so all of this kind of starts adding up to what we probably had in the past in the solar system. We had a planet with a lot of CO2, we had a planet with the lack of water, and then we had Earth that seemed to have conditions necessary for life to form. But the thing is, what if you find a planet that has even more water than Earth? So that's the third scenario. Imagine a planet that has very similar everything, but just has way more water, a water world. Well, this water world will have a lot of oxygen and nitrogen on the surface, but it's also going to have a huge presence of water that's going to create a lot of pressure, very likely completely shutting down all of the geological activity on the surface. No plate tectonics, very few, if any, volcanoes, and thus inability to recirculate certain parts of the atmosphere. So because of all of this water on the surface now, the oxygen cannot actually get integrated into rocks like it did on Mars. And obviously the water vapor is produced in really large amounts, the water is still being broken apart, and more oxygen is being produced everywhere on the planet. There's also not a lot of volcanic activity, and because of this, not enough carbon monoxide is produced to try to capture more of this oxygen. And so what you end up having is a planet extremely rich in oxygen, at least after a few millions and billions of years, yet none of this is produced by life. It's really just produced by the water on the surface that's being broken down by the UV light coming from the star itself. And although this planet might resemble a habitable world and might actually fool us into thinking that there is life here, there's nothing alive about this planet. It's all just chemical reactions. And so these three conditions ideally show us that you can start with an Earth-like world with slight modifications and end up with oxygen in all three conditions, yet no life whatsoever. Three very important false positives. Yet at the same time, if you were to take Earth and to have Earth with exact parameters as we have today, which scientists do in their paper as well, and then run the simulation for billions of years, you would not have oxygen on the planet. All of the oxygen produced on Earth is definitely from life. And we know this as a fact mostly because of the observations from various minerals, from various investigations of fossils in the past, and we even know that some of the oxygen on the planet was very toxic to early life. So by finding oxygen on any of these planets, we might actually reconsider the idea of seeing life there. Generally speaking, oxygen is sort of toxic. Fun fact, if you pressurize oxygen to, I believe, about 4 atmospheres, it also becomes toxic to humans, which is kind of counterintuitive. But that's a fact that's known to pretty much most scuba divers. You are absolutely not allowed to breathe pressurized oxygen because you're basically going to suffocate. This is actually known as oxygen toxicity, and you can kind of learn more about this from the link in the description below. And so the important implications from this study is that when we're looking at those stars and those planets using new telescopes such as James Webb Telescope, we really have to look for other wavelengths of light as well, making sure that we identify all of the possible molecules in those atmospheres. If there's oxygen, does it also have a lot of CO2? Are we also seeing the presence of some other molecules that would indicate that all of this is just geochemical reactions? And a lot of these new studies that are going to be coming out about this are very likely going to determine exactly what proportions to look for and what type of molecules we should be looking out for if we actually want to identify a planet as potentially living and habitable, or just a very interesting, completely natural and uninhabited planet that just happens to have oxygen on the surface. And with so many different planets already discovered and so many different planets that are going to be analyzed in the upcoming missions from the James Webb Telescope, we're definitely going to be finding these oxygen planets all over the place. And I can guarantee that in a few years you're going to hear a story about discovery of oxygen and thus life on another planet. But that is why we have to be really careful when we do discover certain molecules in certain atmospheres. Studies like this, identifying exact false positives, are very important in identifying what is it that we found and what created that certain element on that certain planet.
Семейството и то е като бизнеса. И ти разпределяш бюджети, и ти потушаваш конфликти, и ти имаш разходи за маркетинг, и ти имаш нов началник на главата, и ти имаш представителни разходи, и си експерт в това да държиш акционерите доволни. Вече 20 години.
Hello wonderful person, this is Anton, and today we're going to be talking about the mysteries of outer space. And actually the mystery in this case is going to be the discovery of some other unusual rogue planets. Because even though we technically think that the space out there is more or less empty, in reality the interstellar space is actually filled with various unusual objects. Anything from various types of dust and various types of clouds that seem to be all over the place, with the biggest one being the local interstellar cloud that we're currently flying through, to a lot of other unusual objects such as large asteroids, large comets, and probably a lot of planets, something that we've been discovering more and more of by using various missions and various telescopes, with the best example being this right here, OGLE, Optical Gravitational Lensing Experiment, ran by Polish scientists but located in Chile. But since the majority of these objects are extremely dark and have no illumination of any kind, it's naturally almost impossible to see them. And so the only technique we know of that effectively finds these unusual objects out there is the technique using gravitational lensing, which is exactly how the majority of rogue planets, or planemos as they're also known, have been discovered in the last few years. With some of the other ones, like the first one ever found, OTS-44 that you see right here, being discovered because they do emit a little bit of infrared light that we can actually see by using very powerful telescopes. Here's another one with the name you see right here that was discovered back in 2013 by essentially looking at it in infrared light. Now the closest one to us that's confirmed is at a distance of about 80 light years away from us, and so we haven't really found anything in the nearby vicinity. And because of this, there are essentially two major methods of detecting these. Either we look for these larger brown dwarf-like objects that seem to emit a lot of infrared light, which technically should not really be classified as planets because they kind of belong to their own class. These are really more brown dwarfs than planets. Or we can occasionally find them when they pass in front of a distant star and bend the light in just the right way, producing the optical lensing effects. Now these are the ones that are most interesting, mostly because it allows the scientists to measure their mass quite precisely. And these are the ones we're going to be discussing today because the recent study was able to identify 27 separate optical lensing effects, suggesting that they discovered rogue planets. But a lot of these have already been confirmed by some of the other studies, so they're not new discoveries. In this paper, however, they did identify something that was not seen before. They found several planets that seem to be, overall, quite similar in mass to planet Earth. And this is what makes this study particularly intriguing. They discovered several Earth-like rogue planets. And since the first Earth-like rogue planet was discovered only a few months ago in October of 2020, this makes the study extremely intriguing. So first of all, from some of the previous discoveries, especially the ones that involved brown dwarfs, the scientists realized that these objects can definitely be created in a somewhat similar manner to a typical star. They are made from a molecular cloud material and they essentially coalesce into a protoplanetary disk. In this particular case, this disk was discovered to be approximately 10 Earth masses in mass, which means that this rogue planet or this brown dwarf eventually will have its own moons as well. But since it's only about 12 million years old, it's still developing even now. But then there are these other objects, the much smaller ones, or the objects that do not really qualify as brown dwarfs. Now these have a very different creation story. In this case, they most likely just got kicked out of various star systems, Now, we do believe that there was an extra planet in the solar system, for example, based on various simulations, and this planet was probably also kicked out as well. And so these types of planets are the ones that are most interesting because they are actual planets. They were probably created in various star systems, but through the interaction with other objects in the star system, eventually became their own travelers. And the thing is, current analysis suggests that there are at least 100 billion of these, possibly even more, possibly even trillions of these in the galaxy itself. And so if we were to look at this map again, where the sun is located, according to these theories, there should be tons and tons of these rogue planets located between all of these stars, floating around without being seen simply because they're just a little bit too small and definitely too dark. But in this particular study, the scientists did something that hasn't really been done very well before. They used the data from a telescope that was never meant to study rogue planets. They used the data from the famous Kepler telescope. As you might be aware, the main purpose for the Kepler telescope was to literally just look at the same spot in a galaxy for a very long time in order to detect various tiny shadows passing in front of distant stars. It was looking for the transits of various exoplanets, which allowed it to discover several thousand exoplanets over the last few years. And so the scientists behind this study decided to apply an algorithm looking for a very specific observation. They wanted to find something that would produce the observation resembling this. When a somewhat bright object passes in front of some sort of a mass, it's going to produce the lensing effect with an extremely specific increase in brightness representing this, the Einstein's lens. And depending on the mass of the object, it would last anywhere from a few hours to possibly a few days. So for example, a brown dwarf-like object would produce something that would last maybe up to about 10 days, with an Earth mass object producing something that should only last for a few hours. Which of course also means that it would be a lot more difficult to detect these low mass objects. And so by using the data from approximately 2 months of observations of Kepler telescope, they've definitively identified 27 different signals using this new algorithm. But in those 27 signals, the majority was already known from some of the previous studies, from some of the previous observations. But 5 of them were completely new and have never been seen before. Here's what all of this would look like if you were to actually look at this in the data. So these 4 right here are relatively similar, at least in terms of the potential mass, and they do seem to represent a mass that's very similar to planet Earth, with the 5th candidate being really intriguing and somewhat interesting, almost as if this is some sort of a binary system. Here's another look at all of this from a slightly different graph with a little bit more analysis. So the 4 candidates here seem to be more or less the same, with the last 5th one being slightly more unique. And since prior to this we've only really seen one other Earth-like rogue planet, this does present a super interesting opportunity to study this further. But the problem is that we'll probably never see these objects ever again. Statistically speaking, they might have another gravitational lensing effect in the next million years or so, which means that we're not going to be seeing these exact objects. But we might be able to detect a lot more of them when the new telescopes, such as for example the Nancy Grace Roman Space Telescope, become operational in the next few years. And so by applying the same technique, by using the same algorithm, and very likely the same observational technique, the scientists could now potentially discover hundreds and maybe even thousands of these rogue planets flying through the emptiness of space in complete darkness. For all we know, we might actually be really surprised at the numbers we discover in the future. And we might also realize that space is not so empty after all. But I guess the cooler part of this particular study is how they managed to use the old data from a telescope that no longer even operates to find something that it was never meant to find to begin with. They managed to use the data and mathematical analysis to almost look for the opposite of what the telescope was built to do. Normally it's supposed to find dips, but in this case they managed to find these brightening events that can only be caused, or at least can generally be caused, by something like this. And so chances are that this particular technique is definitely going to be used again to try to discover even more of unusual planets using some of the other data from, for example, TESS telescope. So only future will tell what the scientists discover. But until then, I guess that's all I wanted to mention. We don't really know, or will probably never know, what kind of planets these are, other than maybe predicting their total mass. And just knowing the mass is just not enough to determine anything else. And because there's only one observation, that's unfortunately not going to tell us anything. And so because of this, for now at least, that's all I wanted to mention about rogue planets and recent discoveries.
Meet and repeat.
Hello wonderful person, this is Anton, and today we're going to be talking about a potential discovery of a pretty exciting planet around an iconic star. A star that all of you might have seen in the night skies, a star known as Vega. So in some sense, we might have discovered a vegan planet. Yeah, not a vegan, a vegan planet. And in this case, the planet itself might be super extreme. But let's actually talk a little bit more about this because if confirmed, this is going to be a very exciting discovery. Now, first of all, as you probably know already, we've discovered over 4,000 different planets already as of 2021. Most of them were actually found this way, by looking at the shadows. But some of the iconic stars like Vega, stars that are extremely bright and very well studied, surprisingly seem to not contain any planets around them. Vega is only about 25 light years away from us, and it's also one of the brightest stars in the night sky. So bright as a matter of fact that it's visible in twilight and it's also visible in light polluted areas, which actually allows the scientists to study it from anywhere on the planet. And apart from our sun, it's the second most well studied star out there, which means that in the last few years we should have found something around it. And in the last few decades there have been a few reports of potential planets here, but so far all of them have been more or less discredited for one reason or another. Here's actually the artist's impression of what the planet here might look like. Now interestingly, look at the star itself. It's very unusual in shape and obviously it's very bright and very different in color from our sun. And that's because this is what it looks like compared to our sun. As you can see, it's sort of egg-shaped. Now you can probably guess why this is so. That's because it spins really fast. For our sun to go around its axis once, it usually takes it about 25 days. But this much larger and more massive star only takes about 16 hours. And because it spins so much faster, it basically got flattened over time due to the centrifugal forces from the relatively fast rotation speed. But because it spins so fast, it also possesses some other extreme effects. One of them is related to its magnetosphere. It's very likely that this star has extremely powerful magnetic emissions, and this is one of the discoveries in this paper as well. And it's also a much younger star than our sun and has about twice the mass of our sun, which also means that it's not really going to live as long. Because it's so much more powerful and because it emits so much more light, it's going to reach the end of its life much sooner as well. But for decades, even though the scientists kept looking at this star and trying to discover any kind of shadows of planets passing here, they couldn't really find anything. And for many years, the speculations about the planets around the star have been going on, but there was no actual proof. But here's the thing though, using a different method known as radial velocity, and by essentially looking at the star as it wobbles around a central point, and also by combining this with 10 years worth of data and observations, the scientists might have actually found something after all. And that something is a planet, but it's extremely close to the parent star, with the orbit roughly looking like this. And because it's so close to the parent star and because the star is already more massive and more powerful than the sun, this means that this is an extreme planet. The temperatures here suggest that it's probably the second hottest planet ever discovered, with the temperatures on the surface reaching 3000 degrees Celsius or about 5400 degrees Fahrenheit. And that's actually hotter than some of the stars we've discovered out there, and that is absolutely extreme. The data also suggests that this is probably some sort of a Neptune-like planet with the mass of about 20 masses of planet Earth, and a single orbit only taking about 2.43 days, suggesting of course that this planet is very likely tidally locked to the star, meaning that a single side is always pointed toward the star, with the other side always being in darkness. And the scientists know all of this simply by looking at the wobble of the star across those 10 years of observations. Here they noticed that the star was wobbling by changing its velocity around the central point by about 6 meters per second. In other words, something was causing the star to change the velocity by this much. And all of this was happening every 2.43 days. Here's actually a rough simulation of what all of this looked like. Notice how as the planet orbits around the star, this velocity graph changes as well. Now in this case you'll notice that it's about 9 point something meters per second, That's because I actually chose a planet that's a little bit more massive. But by adjusting the mass a little bit, you'll notice how the graph here will fall down to the amount that they discovered. And so here with the planet of about 12 masses of planet Earth, the velocity is roughly around 6 meters per second, just as they've discovered in their study. And this particular technique is very well known and very well understood, so there's actually very little in terms of interpretation of what's possibly happening here. But in this case, we're looking at this orbit if it was completely aligned toward us. The thing is, we don't really know exactly what the inclination is, and so the minimal mass of this planet is probably around 20 masses of planet Earth. That's according to the scientists behind this paper. With this object that I guess we can refer to as Hot Neptune, most likely also being extremely inflated and possibly even larger than Jupiter in size, simply because of the extreme heat generated here, with the heat being so high that it most likely also evaporates metals. So the atmosphere here very likely contains a lot of things like irons and nickels and a lot of other stuff. It's one of those planets where it's actually raining metal. But unfortunately, because this star is so extremely bright and so extremely powerful and also spins so fast, a lot of signals and a lot of observations coming from this object are somewhat difficult to analyze because the star actually produces so many frequent variations and it's a variable star as well. And so even finding this object and discovering the patterns in the light coming from the star was actually extremely challenging for the scientists. But also being the fifth brightest object in the night skies, this is one of the most important stars out there. And so finding a planet in this star system would actually be a huge revelation. So in this case, it's probably one of the more important discoveries of the year so far, assuming of course it's confirmed. But because the star system is only about 500 million years old, and also since it's already halfway through its lifespan, it means that the planet here is definitely much younger than anything we have in the solar system and will probably perish by the time the star starts expanding and turning into a giant. And apart from the potential planet, the scientists also discovered a potential magnetic variability of the star. It seems that approximately every 0.6 days, it seems to have some sort of a variation of the magnetic fields, which implies that its magnetosphere and a lot of activity on the surface here changes quite a lot, approximately twice per day. And this would of course imply that this is not a star you would want to live around because it changes way too much and it's just extremely unpredictable. And so finding any kind of a life around the star system or especially on this planet is most likely out of the question. But if this planet is really there, the scientists in the paper suggest that there's probably a pretty easy way to confirm it. It's actually using another method known as direct imaging. That's when you cover the star itself and try to look for a very hot, very bright object next to the star. Because this particular planet is so hot, it should be visible pretty quickly and we should be able to see it using some of the modern techniques. But whether there are other planets here is of course another question. One thing that we know about the star system already is that it does seem to have a debris disk around it. So in some sense, something similar to the asteroid belt that we have in the solar system. But this debris disk seems to be more or less flattened and also quite smooth, which actually suggests that there's probably no other massive planets in the system. Any other planet present in the system would have skewed the disk or possibly disturbed it in some other way. Although interestingly, the creation of this disk is another story. It has been implied that it was created by a collision of two different objects, possibly planets. Which of course obviously suggests that the planets used to exist here, but then turned into this very large disk. But does it actually have at least one planet? Well, that's of course another story, something that we'll probably learn in some of the future studies. Interestingly though, Vega is actually the second photographed star ever, after the Sun. And because of this, it's also one of the most well-studied stars out there. And the fact that after decades and decades of looking, we haven't actually discovered any planets here until now, does imply that maybe, just maybe, this particular planet is also not there. Maybe it has some other explanation. So this is why future studies are needed to discover what's really happening here. And also just a fun fact, about 12,000 years ago, this was also the northern star of our planet. It was pointing directly at the north. And it's also going to become the northern star in the next 13,000 years or so. And so in that sense, if the humans are still around 13,000 years later, we might actually think of the star in a completely different way. But I guess for now, that's all we know. It's a really cool star. It might have the second hottest planet we've ever found, and it also might have a lot of other mysteries around it, something that we can't really answer just yet. Some of the future studies might help us answer the question of whether this planet is real or not, but for now we don't really know.
Довери се на Фрискис за балансирано хранене, за сигурно качество, за проследимост на продукта, за гарантирана експертиза, за грижа към планетата. Научи повече на Purina BG.
Hello wonderful person, this is Anton, and today we're going to be talking about this really interesting and somewhat intriguing planet that was discovered back in 2018 and about which we've learned quite a lot in the last few years. The planet that seems to be the first confirmed candidate for having what we refer to as tectonic activity. In other words, this planet probably has a lot of volcanoes and also possibly even plate tectonics similar to planet Earth. Well, let's talk a little bit more about this planet and about how the scientists discovered all of this, starting with some of the parameters we know about this planet and what it might sort of resemble. We know that this is a planet that seems to have absolutely no atmosphere or extremely thin atmosphere. It's also extremely dark, possibly similar in color to Mercury, with somewhat dark and non-reflective surface. The temperatures here are also relatively high on one side and super low on the other side. And that's because this planet is, first of all, completely tidally locked to its parent star, which of course suggests that one of the sides is always pointing toward the star and the other side is always on the dark side, with the average temperature right here on the bright side being about 770 degrees Celsius or about 1400 Fahrenheit, with the dark side possibly being close to absolute zero. And with a single orbit here only taking about 11 hours, and with the planet itself being about 1.3 times the size of planet Earth, this is actually a somewhat unusual and somewhat interesting object. It's a terrestrial planet, but it's extremely close to the parent star and thus has very unusual and obviously super extreme conditions on its surface, something that we don't have in the solar system. Now, the best artistic representation of what the surface most likely looks like is right here. And this is of course based on several studies that establish that there's most likely no atmosphere and this is a very non-reflective dark planet. But this is actually lacking some of the more recent discoveries coming from the simulations described in the paper you can find in the description. But I guess the question here is, how do we possibly know any of this? Well, by looking at the planet and also by looking at the reflections coming off this planet, and specifically what's known as the phase curve, the scientists for the most part were able to figure out the atmosphere and the reflectivity of the surface. For example, here is what the phase angle or the phase curve looks like for Venus and for Mercury. And so here, by looking at Venus from planet Earth and also by looking at Mercury from planet Earth, and then by comparing the phase angle, which is described in this picture, with the total magnitude of the planet, we can actually start seeing some interesting patterns. For example, for Venus, for the cloudy planet, you'll notice how it's much more shallow and it actually has this unusual brightness excess right here, usually due to the reflections from its cloud layer. For Mercury, it has no clouds and it's also a really dark planet, so it has a much more steep phase angle, which is even more steep than planet Mars. And by using this sort of analysis and by essentially comparing this to what we know about other planets, the scientists can usually determine what the exoplanet might actually contain on its surface as well, or at least if it has clouds or no clouds, and if it has very dark regolith or dark rock, or if it has reflective surfaces. And by using this sort of analysis and combining it with numerical and computer simulations, and by simulating various types of tectonic materials and also various types of heat sources, the scientists were able to establish that this planet very likely has a lot of volcanic activity and potentially even other types of tectonic activity on the surface, with one of the better representatives of what it might look like being this moon right here known as Io, the moon of Jupiter, Although here the number of volcanoes and also just the sheer number of activity is most likely much smaller than it is on this particular planet. And what's even more interesting here is that the scientists established that all of this activity very likely happens on just one side of the planet. They're not entirely sure which side though, but they kind of think that it's probably on a side closer to the sun or closer to the star. Which of course implies that one of the sides looks something like this, possibly even more extreme, with a lot of volcanoes everywhere, yet the other side being extremely different and potentially even completely devoid of volcanoes. But unlike on planet Earth, the simulations here suggest that the flow of matter inside the planet most likely does not really circulate up and down like it does on planet Earth, as you see in this particular picture, but instead seems to circulate across the entire planet. And in this case, on the hotter side, it's most likely going to be flowing upwards, whereas once the material reaches the other side of the planet, it might actually start flowing downwards. Which suggests that there's probably a lot of volcanic activity and a lot of tectonic activity closer to the surface facing the star. But that's not entirely certain because simulations actually have showed the opposite as well. And so on whatever side the material is moving upwards, that's the side where we would expect a lot of volcanic activity. In this particular illustration, the artist decided to put the volcanoes on the dark side of the planet. And interestingly here you can even see all sorts of emissions on this side, with the side facing the star itself being extremely dark and empty of anything. But once again, what side has the volcanoes is actually not certain because we can't really see this just yet. And this is of course very different from what we see on, for example, Io, which has volcanoes pretty much all over the surface. And it's also somewhat different from planet Earth as well, even though on our planet we do have certain locations where there are more volcanoes, such as for example in Hawaii or in Iceland. But at the same time, there is actually at least one object in the solar system that might have experienced something extremely similar. And sometimes we get to see this object pretty much every single day. That object is of course our moon. And today we know that the moon's surface, the one facing planet Earth, has actually undergone a tremendous amount of volcanic activity. Some scientists have even suggested that some of the recent volcanic activity was about 100 million years ago. Yet the opposite side, the one we don't really get to see with our own eyes, but that we have pictures of from various missions, is exceptionally different. It does not have anything in terms of volcanoes. And the lack of volcanoes here and the huge presence of volcanoes here has been explained previously as the result of tidal activity from our planet, and also as a result of various materials surfacing over time and heating up the surface of the side closer to us while leaving the other side completely intact. And so whatever is happening on the surface of the planet LHS 3844b might be extremely similar to the moon in the past, and this is of course due to the tidal effects from its star, combined with the fact that it also has extremely hot surface on one side and very cold surface on the other side. And also, just like the moon, it doesn't really have any atmosphere, which overall makes this object extremely interesting for some of the future studies. But until we have better telescopes to actually look at this object and to also see if there's any volcanic outgassing like you see right here that we can possibly detect, or any other features such as actual illumination from the volcanoes, we're not really going to be able to know much more about this planet. Right now this is still based on computer and numerical simulations, and it's also based on phase curves which are not super accurate because this object is 48 light years away from us. But future studies and of course future observations might actually help us determine if this is indeed the second ever object discovered that does seem to have a lot of tectonic activity on the surface. Kind of similar to some of the other objects like, for example, Venus in the past, Moon in the past, Io in present, and of course planet Earth, which at least for now is the only object we know of that has extremely active tectonic activity, which is also responsible for preserving the biosphere of planet Earth. And so finding other planets where tectonic activity is going on is extremely important. But more important right now is for us to find better techniques to essentially learn how to identify if these planets are tectonically active. If they do have volcanoes and of course plate tectonics, those planets are going to be extremely interesting for future studies. And so hopefully, thanks to studies like this, we'll be able to identify future techniques that will help us find more of these planets. But I guess for now, that's sort of all we know about this planet. It's definitely exciting to know that it probably has volcanoes and maybe even plate tectonics, and it might have also experienced something similar to our own moon, but I guess until future studies we're not going to know much more.
Казват, че с приятели всичко се споделя. Особено любимото Нескафе 3 в 1. Точната комбинация от богат кафе аромат и неустоим вкус всеки път. Казват също, че каквото откриеш си остава за теб, но защо не го споделиш? Нескафе 3 в 1. Създайте моментите заедно.
Събрахме топ кулинарни инфлуенсърки, за да създадем най-вкусния и сладък десерт. Всяка на драго сърце издаде своите тайни. Едната донесе домашни яйца, другата мляко, третата мед и мъла. И като започна едно бъркане, едно месене. И така се роди приказното кейкче Милкис. Обаче някой трябваше да го опакова, да изглежда и отвън добре. И тогава поканихме Трендафил от една друга реклама. Милкис. Да ти е сладко. Айде, баба. Без хляб си го изяш.
In the last few years, we've discovered quite a lot of exciting and really interesting exoplanets out there, with certain star systems even possessing exoplanets that could potentially be habitable and maybe even have some sort of an extraterrestrial life on the surface. But as our techniques improve and as new instruments are being developed to see even more, we keep discovering even more exciting worlds out there. Hello, wonderful person. Today we're going to be talking about yet another star system out there that has recently been discovered to have 5 exciting exoplanets, with one potentially habitable and one that seems to be approximately 1/2 of the mass of Venus, yet at the same time being the smallest planet discovered using a really exciting method. So let's talk a little bit more about this unusual star system known as L89-59 and find out what sort of planets we think they are as well. First of all, this is actually not the original discovery. The first time 3 of the planets were discovered was back in 2019, and back then, by using the TESS telescope, the original discoverers identified 3 potential candidates for what seemed to be exoplanets. It wasn't really confirmed right away, and the scientists were not certain what sort of planets they were, but the initial suggestions all suggested that they were actually terrestrial, relatively similar in size and in mass to planet Earth. But now, 2 years later, following more thorough analysis and investigations using a slightly different instrument, these scientists were able to establish relatively accurate measurements of mass, density, and also discovered 2 more exoplanets hiding somewhere in the star system, with one potentially habitable and being located right in the middle of the habitable zone as well. And now let's start right here. This is the image created by the European Southern Observatory. This is the solar system with Mercury, Venus, and Earth, and that's the star system we're talking about, L98-59. In this case, you're not actually looking at distances, but instead this diagram is scaled in order to make the habitable zones of the solar system and the other star system to match in the same region, with the rest of the picture showing us a kind of a temperature scale or a temperature gradient away from the star all the way to the end of the habitable zone. And since this is Mercury, it means that in L98-59 there are 2 planets that are even hotter than Mercury. But I think the most exciting part about this study is actually how they found these new planets and also what they used to analyze the original discovery as well. First of all, this is at a distance of about 35 light years away from planet Earth, so not too close, but also not really far away either. In order to perform a new analysis, the scientists from the European Southern Observatory used the most powerful spectroscopic instrument known as ESPRESSO that collects the light from the ESO's telescopes and then analyzes the changes in the frequency of light in order to see if the star itself is being pulled at by anything else. Okay, so it's actually easier to understand this if I show you a visual example here. So this right here is our sun, a copy of our sun. Right now it doesn't actually look like it's doing anything, and it doesn't look like there are any planets in its orbit. But once I zoom out, you'll notice there's a planet Earth, and it's orbiting in the same area where actual planet Earth orbits as well. But how can we possibly find it if there are no other signs for this planet, if there are no actual indications, no shadows showing, and no other way for us to see anything? Or in more scientific terms, it doesn't show us any transits, there are no shadows. Well, here we have a different method, and this is called radial velocity. This method works with a very simple principle. Because the planet and the star both contain mass, they actually end up sort of dancing around one another. Obviously, the planet being less massive moves a lot more, but the star is also sort of wobbling around a central point. Now for the solar system, our Jupiter does most of the pulling. It actually moves the sun by quite a lot. But even our tiny planet Earth has a bit of an influence on the sun. It shifts it just enough that if you were to have a powerful instrument, you would be able to find it. And that's precisely what Espresso does. It looks for these tiny wobbles, and it finds those wobbles by looking at redshift and blue shift effects coming from the star. And so once again, if you look at the simulation from NASA here, notice how as the planet moves around the star, it either blue shifts or red shifts the light from the star. It's not a very dramatic effect, but if you have a powerful instrument, you can actually see this, and it's going to be periodic, and it's going to be detectable using modern methods. Here we're talking about changes in just a few hertz of frequency. Okay, so going back to our sun here, if I were to show you what's happening to the velocity of our sun by actually using the frequency change observations from the sun, it would sort of look like this. Every once in a while, specifically every 365 days, the velocity of the sun would change by about 18 centimeters per second. And that's because the Earth is pulling at the sun and is making the sun wobble just a little bit. And so that's kind of what the scientists in this paper did and analyzed the frequencies coming from this particular star system, eventually realizing that certain frequency changes seem to have a period coinciding with a potential planet orbiting in the region. And because 3 of these planets have already been detected using another method, they were able to confirm the existence of these 3 planets, but also discovered the mass of these planets, which allowed them to discover the density, and then discovered 2 more potential candidates. And so here the analysis suggested that the nearest planet seems to be about half the mass of Venus, approximately 0.4 masses of planet Earth. But because this planet is so close to the parent star, it's also probably kind of hot here. Nevertheless, this is definitely a rocky planet. The second object, which originally was thought to be some sort of a Neptune-like object, is also very likely a terrestrial world, a somewhat hot terrestrial world. And with a mass of about 1.4 masses of planet Earth, this is also a pretty exciting object that they were able to discover. The third object, which is a lot cooler in this case, is also pretty massive. It's about 1.5 masses of planet Earth, but for some reason it also seems to be a lot less dense. In this case, the scientists think that it's because it's an ocean world. It probably contains about 30% of mass as water. But because of its location in the star system, it's really unknown what sort of conditions this water is in. It could be just a really large steamy planet because it's actually pretty hot here, or maybe it's extremely hot and steamy on one side, but actually has a liquid ocean on the other side. So this could also be an extremely interesting object that they discovered. Here's the artistic representation of what this world might sort of look like. Although obviously it's not clear if it's actually blue like you see right here, or if it even has the water on the surface. But then they found 2 more planets, potential candidates, slightly farther away, but in
Избери OMG Max Motion 100 за максимално представяне. Новата формула, обогатена с ActiveFlow частици, намалява
the area that's more habitable. Neither one of these planets transits in front of the star, so it would actually be impossible to see their shadows or to study their atmospheres, but they do seem to be there based on the observations from Espresso. So this one here is roughly around 3 masses of planet Earth, and it orbits around the parent star every 12.8 days. Now this might sound like it's really fast, but because this is a red dwarf, things here happen a lot faster as well, and this is why the planets are so much closer too. The star itself is about 3 times lighter in terms of mass than our own sun. It's about 0.32 masses of the sun. But it's really this last detection that seems to be the most interesting. First of all, because it's pretty much in the middle of the habitable zone, with the average year being about 23 days in length. But also because it does seem to be terrestrial, with a mass of about 2.4 masses of planet Earth. And depending on the atmosphere and a lot of other conditions, this planet has a huge chance of having actual terrestrial conditions on the surface. But unfortunately, since it does not pass in front of a star, we're not going to be able to study its atmosphere until some of the other techniques come out, or some other advances in telescopes or new instruments. So for now, we can only really estimate the mass of the planet. We're not going to know what else is going on here. Nevertheless, it's still pretty exciting to discover yet another multiplanetary star system in a relatively close neighborhood, about 35 light years away from planet Earth. And because there are 5 planets here, with all 5 maybe even terrestrial planets, this of course makes it one of the most exciting star systems discovered in the last few years. More importantly though, it allowed the scientists to really push espresso to its limits. For the first time ever, they were able to confirm an actual relatively small in mass planet by using the radial velocity method. And in this case, the planet was only about half the mass of Venus. This is the smallest planet to have ever been discovered using this method, or I guess in this case rediscovered, or confirmed. Unlike the example that I showed you with our Sun and planet Earth, where the actual change in velocity is about 18 centimeters per second, planet B was actually changing the velocity of the star by approximately 46 centimeters per second, essentially making this the record as of today. But we know that espresso can actually see even smaller planets, or even less massive planets. Its limit currently is about 10 centimeters per second, which means that at least hypothetically, if espresso-like instrument was looking at planet Earth, it would definitely be able to detect it orbiting around the Sun. Which of course also means that we're going to be discovering more of these planets with possibly even smaller objects out there in some of the future studies. Hello wonderful person, this is Anton, and today we're going to be talking about ancient planets. Actually, oldest planets in the galaxy. And specifically we're going to be talking about the new discovery coming out of NASA and out of TESS telescope, the discovery of a planet known as TESS 561b, which seems to be one of the oldest terrestrial planets we've ever found, which also raises a few mysteries that we currently can't answer. But before we talk about those mysteries, let's also talk about other planets we've found in the last few years. Starting with, I think, the most famous planet, known as the Methuselah planet, named after Methuselah, who I believe was a biblical character known to have a very, very long life. This planet, however, hasn't beat by a few billion years. This beautiful Jupiter-like object, this gas giant known as PSR B1620-26b, is an exoplanet roughly around 12,000 light-years away from us, located in the middle of a very large and very well-known globular cluster. And because we can estimate the age of a globular cluster relatively easily, and because we also normally think that a lot of stars in globular clusters appear at the same time, we believe that all of the stars here have very similar age. And in this case, we think that it's about 12.7 billion years. But unlike a typical planet, this particular planet also has a very strange star. It actually orbits a neutron star, in this case a pulsar. And to make things a little bit more interesting, the star system also has another star, a white dwarf, in orbit around the neutron star. So essentially, apart from being the oldest planet we found so far, the Methuselah planet also has two different stars that it orbits, one of them being a white dwarf and one of them being a neutron star. So it does have a lot of records. But this is a gas giant, so in that sense it's not as interesting as discovering a terrestrial planet. And finding ancient terrestrial planets has actually been very challenging. As a matter of fact, most scientists believe that finding ancient terrestrial planets would be practically impossible. But in 2015 we've discovered one such unusual star system known as Kepler 444 that has 5 different terrestrial planets with an average age of close to about 11 billion years old. Now this system was extremely unusual, especially because a lot of the planets here were in a relatively close orbit to the parent star, and also because the star itself was not that different from the Sun itself. This was a K-type star with a mass of about 80% of the mass of the Sun. Discovering such a system was very unexpected. And so finding such an ancient star system, especially not very far away from us, only about 120 light years away from planet Earth, was not something a lot of scientists expected, and it was definitely kind of unusual. But then for pretty much 5 to 6 years now, we haven't really found anything else so strange and so ancient. And that's of course until very recently, when the scientists were able to use the TESS telescope to identify yet another strange, ancient terrestrial planet somewhere out there. At a distance of about 280 light years away from us, this is sort of what the system looks like, with the star itself being extremely similar to our own Sun. This is a G-type star. But because it's over 10 billion years old, it means that this is almost the end of this particular star system. This star is soon going to reach the stage when it's going to start expanding and will definitely swallow all of these planets. But the planet of interest is this one right here. This is what NASA believes it might look like on the surface. It's currently known as TOI 561b, and here's sort of what it looks like compared to planet Earth. It's about 1.5 times the size, but surprisingly has an almost exactly the same density as planet Earth. which of course suggests that its composition is extremely similar to what we have here as well, although it is possible that it's slightly different and maybe has some other dense materials inside of it. But the major difference here is of course the distance to the star itself. Here, a single orbit takes about 0.4 days, which also means that the temperatures on the surface are ridiculously high, probably around 2500 degrees Kelvin, which sort of makes it the same temperature as on the surface of some smaller stars. And to give you a much better visual analogy of what this might look like, it probably looks something like this. It's literally a lava world with one side always facing the star and the other side always being in the dark. We don't really know what happens on the surface, but we do know that these extreme conditions also create some unusual atmospheres on the surface. For now, we don't really know what this atmosphere is just yet, we just know that it's very different from anything we can imagine. And just like in the Kepler 444 system, there are at least 2 more planets here that are potentially terrestrial, although maybe also something known as the super-Earth, and 2 planets that seem to be Neptune-like, which would probably make them look something like this, or maybe something like this. This is according to some of the NASA simulations. But as you can see from this simulation, these unusual 5 planets all orbit extremely close to the star, within the orbit of Mercury, which of course implies that in a few 100 million years, when the star starts expanding, all of these planets are going to be gone forever. But the most important discovery coming out of these star systems is not that they're old, but that the universe was creating these terrestrial planets for billions of years. Nobody actually expected we would find such ancient terrestrial planets somewhere out there, and especially ones with composition and density similar to planet Earth. This means that these planets, terrestrial planets, may exist and also remain stable for billions of years, which is great news for those scientists that are searching for extraterrestrial life somewhere out there, or that are searching for some other planets similar to planet Earth. These discoveries imply that many different ancient terrestrial planets exist out there, and some of them could have probably maintained conditions that we would call habitable for a very, very long time. Now, obviously it's none of these planets are just too hot and too close to the parent star, but discovering these planets definitely helps us in our search. But one of the more unusual mysteries about this planet right here, the closest planet to the star, is its high density. Because these planets are so ancient and because they were created long time ago, we would expect the stars where these planets are located, along with the material that these planets are made from, to be relatively low in metals, in materials that are not hydrogen and not helium. And because of this, we expect them to have relatively low density. And most of the planets that are usually discovered that have billions of years of existence normally have really low density and for the most part are made out of materials that are hydrogen, helium, and materials that are lighter. They don't usually contain a lot of iron, they don't usually contain a lot of nickel or other stuff that makes terrestrial planets dense and that gives them a lot of mass. But in this case, because this strange hot planet seems to contain relatively similar density and not really that different of a mass and size compared to planet Earth, this suggests that it has a lot of metallic materials inside of it. And that sort of contradicts some of the theories and predictions from these early planetary formation theories. As a matter of fact, theoretically, nobody expected we would even find these ancient rocky planets that have aged over 10 billion years old. But we found at least 2 star systems that have them, and there are several terrestrial rocky planets in each of these systems. And that currently has no good explanation. And so here the only explanation is that either there are some really major exceptions to the rule here, with certain stars and certain planets in the early universe being able to have a lot of these metals and a lot of these materials that would create a terrestrial Earth-like planet, or we might have a mistake somewhere when it comes to the theories and the ideas of planetary formation in the early universe. Either way though, these are exciting discoveries and will definitely help us understand how such unusual planets similar to planet Earth could have been formed to begin with. More importantly though, it will also help us understand how these planets evolve over time, and in some sense will also kind of guide us in trying to understand how the solar system will evolve and what one day might happen to planet Earth and other terrestrial planets like Mars and Venus in our own solar system as well. Hello wonderful person, this is Anton, and welcome to this imaginary version of Tatooine. Well, mostly because I can't really use the real version because I'm sure Disney is not going to like that very much, but also because this wonderful person by the name of Michael Tynior created this really cool free software simply known as Tatooine that basically recreates this iconic scene from Tatooine with the beautiful 2 stars in the night skies. Now by now this scene is more or less iconic, and I think most people today are quite familiar with the fact that Tatooine has 2 stars. And because of this, even astronomers today started referring to these hypothetical planets around 2 stars as Tatooine worlds, or Tatooine lakes, or basically Tatooines. And a lot of scientists today are actually trying to solve the mystery of whether these worlds truly exist. And the reason why it's a mystery, and the reason why nobody really knows if they truly exist is, well, it's actually really simple. It's very easy for a star to hold on to planets when it's just one star in there and not a lot of other gravitational interactions. Like for example, unless there's a massive object like a brown dwarf, it's usually going to be able to hold on to most planets pretty easily. Although even in our own solar system, objects like Jupiter affect other planets and affect the star itself to the point where it becomes quite visible. Our Sun, for example, because of Jupiter, even has its own orbit slightly shifted as Jupiter moves around it. But today we know that most stars out there, actually possibly even like 3/4 of all of the stars, are binary. There are usually 2 stars, and for the most part, most stars in our galaxy have partners. Now because there are 2 stars, there are now 2 gravitational objects, and so it's a lot more difficult for an object to maintain a stable orbit around these stars. Alright, let me help you visualize this. So let's just say I place a random Earth-like object in the orbit of these 2 stars. This is a binary system, and I'm just going to smack Earth right here. All of this is most likely going to destabilize its orbit, and essentially most of these Earths, most of these planets, are not going to be able to maintain orbits around these 2 stars. One of the Earths just collided. And that's because this is a binary system where the gravitational interaction and gravitational stability points are actually constantly changing and are very different. Now it doesn't mean that these binary systems don't exist. They do exist, and they even have their own name, but also really difficult mathematical formula related to those orbits. These are known as circumbinary planets. Circumbinary in this case meaning that they orbit both stars. Now obviously having an orbit around one of these stars is also possible, and that's actually the most likely scenario here, and in this case the orbit is going to be stable, but having an orbit around 2 stars is a lot more challenging, but not impossible, and there's actually a region around these 2 stars where you can still have a pretty stable orbit. For example, here is one of many possible orbits, with the orbit itself being a little bit more eccentric than usual. And we've discovered over the years quite a lot of these different objects that seem to possess these types of planets. Interestingly, one of the first discovered exoplanets that was discovered back in 1993 was actually a circumbinary planet around a white dwarf and a pulsar. But there are not a lot of them, and they are quite interesting to scientists, mostly because, well, it's difficult to imagine how these planets form stable orbits around the stars that do actually produce a lot of instability. Now this is actually one such system discovered by the Kepler telescope. This is the system known as Kepler-16. This is probably one of the more well-known circumbinary planets. And in this case, it's an object that's somewhat similar to Jupiter, but about maybe 30% the total mass of Jupiter. So it's definitely possible for these planets to form naturally. Another good example here is from this interesting system known as Kepler-64, also known as Planet Hunter 1 system, because it was actually discovered by citizen scientists. It was the first planet discovered by citizen scientists, so it's known as PH1. And in this case, this is in a quadruple star system, where the planet itself orbits a binary star system, and the binary star system then orbits another binary star system, making this a very odd and very unusual system, but an actual system nevertheless. And today we even have some really impressive observations from some of the early planetary systems, where the stars themselves are just being born and the planets haven't even formed yet. So for example, here's a circumbinary disk around AK Scorpii, a young star system in the constellation of Scorpius, and this image shows us the ring that will probably become either one or possibly even several planets, but this ring is actually extremely small, it's very thin, at least compared to a typical planetary ring. And so this actually helps us visualize where these stable orbits are. But a much more important question is, of course, well, in regards to this, to Tatooine. Can a habitable planet exist around a binary star system? Or just to rephrase this, can we have a circumbinary habitable planet? And that is the question that the scientists in the study that you can find in the description below decided to investigate, analyze, and mathematically answer. And the short answer is yes, and they even might have found at least one really good candidate. But what's even more unusual about all of these star systems they looked at and analyzed is that they also all possess a relatively massive Jupiter-like object somewhere in its orbit. And so if I were to replace our hypothetical Earth with Jupiter here, well, first of all, it would actually create quite a lot of instability in the system because its mass is much higher. It might even shift the orbits of these two stars. But then eventually they will probably reach some sort of a balance. This, however, will make creation of any other planet in the system extremely challenging. But as the scientists discovered in the study, not impossible. And it seems that it's even possible to have a habitable zone in the system. And so even in the presence of giant massive planets, it looks like there is a chance for certain planets to still exist and still stay habitable. Now, even though Kepler telescope was operational for several years and discovered several thousand different planets around different types of stars, it actually only discovered 12 circumbinary planets, which means that they're either extremely difficult to find or more likely just very, very rare. But pretty much all of these circumbinary planets found by the telescope are, first of all, really massive. They're usually at least the mass of Neptune, so about 20 masses of Earth, but they're also really far away, over 2,000 light years away. So trying to find another terrestrial world in these systems is kind of difficult right now. Until we get better telescopes, we're not going to be sure if there's anything else here. But because there are so many chances for instability from the other planet or even from one of the stars, generally speaking, the conditions for habitability here would be quite hostile. And mostly because of the amount of perturbations that will still be created by the stars. It means that sometimes this planet is going to be really close to both of the stars and thus be much hotter. Sometimes it'll be really far away and much colder, so it's going to be very difficult to have stable conditions on these planets. At the same time, having several massive planets in the system will destabilize this even more. So if there's already a massive Jupiter-like object, it does have a very high chance of perturbing other planets just enough to make them not so habitable. And so in this paper, the scientists took all of this into consideration. They considered the fact that there could be strange, unusual massive objects here. They looked at the class, the mass, luminosity, spectral energy. They also considered gravitational effects from other objects nearby, and a lot of other parameters that normally affect the orbits of planets. And by plugging all of this into various equations, while also considering something they refer to as climate inertia, or basically how fast the climate would change depending on the location in the star system, they did realize that the habitable zones are definitely possible. And so after doing the analysis, the scientists in this paper established that of all of the circumbinary star systems they analyzed, most of them still have a pretty high chance of having some sort of a habitable world, or at least habitable zones. But there are a couple of them that don't actually have a very high chance. Like for example, this one right here, Kepler 1661, has a planet that's a little bit too massive, so the habitable zone, if it exists, is probably really, really small. The planet just destabilizes the system too much, with the biggest habitable zones being around Kepler 35 and Kepler 38. But the best system, or the most likely system to have the largest habitable zone and thus potentially terrestrial planets, is a system known as Kepler 38 that's surprisingly pretty far away from us. It's about 3,800 light years away. But because of the overall structure of the system, the chance for a habitable zone that's stable is really high here. Thus suggesting that one day we could maybe really discover a true world that's kind of like Tatooine. An actual world with two stars, or in some sense binary sunset and binary sunrise. Something that we've been kind of imagining for the past 40 years since the original Star Wars came out. But overall, this paper does suggest that pretty much most of these circumbinary star systems do have some sort of a habitable zone that extends to roughly around 2 astronomical units away from the center. After this it becomes too unstable, and if you're too close to the star system, unfortunately it's too close to the star to be habitable. But because generally speaking it's a little bit more difficult to detect a planet around 2 stars compared to a planet that orbits a single star, it might take a little bit longer for the scientists to finally discover a terrestrial world around a binary system. Hello wonderful person, this is Anton, and today we're going to be talking about the most populous stars in our galaxy, known as red dwarfs. And more specifically, we're going to try to answer the question, can anything actually survive in these star systems? Can any life prosper here? And hypothetically, can life actually produce oxygen? So the question we're going to try to answer is, can photosynthesis occur around red dwarfs? And all of this is based on a relatively recent study that you can, as always, find in the description below, that performed a really interesting analysis of whether certain bacteria can survive in simulated conditions similar to the conditions we would find around a typical red dwarf star. And so in this case, the only purpose of the study was to see if photosynthesis, one of the most important chemical reactions on the planet, can hypothetically occur around a typical red dwarf, or if it's something that we shouldn't even try to look for because it's impossible both chemically and of course physically. And this question is of course really important because most of our knowledge of life is from our own star system, from the star system known as, well, the solar system of course, and the star here is what's known as G-type star, but they're not actually that common. The most common type of a star is this one right here, a typical red dwarf. And moreover, all of the most exciting discoveries of different exoplanets so far, including all of the exoplanets we're discovering right now, the vast majority of them are actually around red dwarfs. Including the most exciting discovery of the nearest star system, Proxima Centauri, and the two planets, with one, Proxima b, being located in the region where we kind of expect liquid water to exist, in the so-called habitable zone. And with all of these other red dwarf systems out there, including the famous TRAPPIST-1 system, it's kind of important for us to understand if life can hypothetically exist here. Obviously, we want to know if life could have developed here naturally, but also if one day we become some sort of a species that learns how to travel across stars and learns how to colonize other star systems, we would want to find out if being able to establish a functioning colony here is a possibility. Can plants grow here? Can we, for example, establish a farm on the brighter side of this planet and use the stellar light for photosynthesis? Because we know, for example, that red dwarfs actually produce a lot less optical light, and as you can see also a lot of flares, and they also don't produce as much light that's usually required by plants. And so even though these stars are really bright in the infrared, they're very dim in the optical frequency of light, and of all of the frequencies, they seem to mostly produce red light. And to try to explain to you why this is a very intriguing question, let's take a look at the difference between a typical red dwarf and our own sun. In this simulation you can kind of see the size differences, but what's not apparent here is the difference in luminosity or the amount and types of light produced. Here unfortunately the red dwarf does seem like a pretty bright star as well, but you can see the more realistic radiance or spectral radiance in this case in this graph. Notice unfortunately the red dwarf does seem like a pretty bright star as well, but you can see the more realistic radiance or spectral radiance in this case in this graph. Notice how a star like our sun mostly produces visible light and also has a relatively high spectral radiance for this light. And these are the frequencies that are normally used by various plants and also various algae during chemical reactions like photosynthesis. But a much cooler star, such as a typical red dwarf, will only have a very tiny amount of light as red light, with only some light being yellow, and the vast majority of it is going to be in infrared or even longer wavelengths, with the total radiance being much lower as well. So not only do red dwarfs have mostly red light, they also seem to have very low amounts of light to begin with, meaning that all of the planets here will be extremely dim, and any potential life on the surface will mostly be receiving a lot of red light. Well, actually no, some red light, not a lot of it at all. But these amounts are so minuscule that it's important to know if anything can possibly survive here. And this is why this experiment and this particular study are so interesting, because they were able to create these artificial conditions that we would expect around a typical red dwarf, and they were then able to test these conditions scientifically by varying certain parameters and also by using certain organisms that we know can exist in these extreme conditions, which also, by the way, includes extreme radiation and potential flare conditions that we can usually find around a typical red dwarf. And by the way, completely unrelated to all of this, and this is more of a sci-fi / geeky fact, but you know how eyes on Earth evolved to see things in the optical light? And we know that In the Predator series, Predator for the most part sees the infrared light as their main source. So it's totally natural to assume here that Predator as a species came from some sort of a red dwarf star somewhere nearby. Which also scientifically makes sense because any life evolving around red dwarfs would most likely develop an ability to see in the infrared, not so much optical light. Anyway, getting off track, back to reality, photosynthesis, and possible life on other planets. Let's start with this map right here. This is actually a map of photosynthesis on planet Earth. Here on land you can see that the dark green, that's essentially the various amounts of chlorophyll on the surface of the planet, with very little here in the Sahara Desert, a lot here in the sub-Saharan regions. But notice how in the waters we also have quite a lot of various hotspots, especially one right here, and also a few right here in the Arctic, some right here, and of course one in the Black Sea and one in the Caspian Sea that also have very high concentrations of chlorophyll and thus the ability to produce oxygen on the planet, with really large amounts of oxygen coming from these regions in the oceans, and specifically oceanic phytoplankton, which usually resides in certain regions around the planet. But all of the life on planet Earth requires light to be of certain frequency, specifically between 400 nanometers and 700 nanometers. Or in other words, between violet light and red light. Anything lower than that in wavelength becomes ultraviolet, and that's actually slightly more dangerous to life because it starts breaking up the cells themselves. But anything longer than that becomes infrared, and infrared just doesn't have enough energy for most of the life on the planet. But in the last few years, scientists have discovered a lot of different specific extremophiles, and here we're talking about cyanobacteria extremophiles, that do actually survive on light that is in infrared. And here we're talking about light that's about 750 nanometers in wavelength. These strange bacteria found a way to survive and to thrive in conditions where no other bacteria can survive because, well, it's not enough energy for them to create necessary chemicals and to initiate photosynthesis. And naturally the next step was to put these bacteria into these experimental conditions and then see if the bacteria could reproduce, survive, and photosynthesize for up to 240 hours. To make this a little bit more scientific, they actually chose 3 conditions. One was very similar to the starlight that our sun produces, one was similar to a typical red dwarf, and the last one was just that infrared light that's about 750 nanometers in wavelength. And I guess not surprisingly, all of the bacteria used in this study were able to survive and thrive in the conditions similar to a typical red dwarf. But a lot of these bacteria were not actually able to grow with just that far red light, mostly because they're not able to photosynthesize and to produce other types of chlorophyll in certain conditions. In other words, these bacteria were actually using some of the available light, such as orange and yellow light, that is also available around red dwarfs. But at least 2 bacteria were to some extent successful even with that little amount of red light, meaning that even in the extreme conditions where mostly the red light is produced by a red dwarf, we should still expect at least some types of photosynthesis to be possible. And so what does all of this mean? Let's jump onto the hypothetical surface of a TRAPPIST-1 planet and briefly talk about the implications. So this is what it might actually look like on the surface here. Now, if we have water, or hypothetical water, and if we have a star that produces predominantly red, infrared, and some yellow light, we might be able to discover certain bacteria and certain algae here that has adapted to basically use these conditions to produce oxygen and to produce other atmospheric conditions that could be necessary for other types of life to develop. And because we're talking about extremophiles here that are able to survive very hot conditions and even high radiation, they could also hypothetically survive very powerful flares coming from these red dwarfs as well. And because photosynthesis is now theoretically possible and because life can hypothetically survive here, the next step would be to start looking for the signs of oxygen coming from the surfaces, from the atmospheres of these distant planets, such as the planets in the TRAPPIST-1 system. But obviously just seeing signs of oxygen might not really be a good proof that some kind of a vegetation or some kind of a bacteria live on the surface of this particular planet. We know that oxygen can be produced through other chemical means. There is, however, a very interesting technique that could be used by the upcoming missions such as the James Webb Telescope that is already used here on Earth to determine, for example, the health conditions of various forests on planet Earth. So the way we study this today is using the phenomenon known as the red edge. red edge in this case being this edge right here at the end of the red light. And this interesting phenomenon applies to all of the vegetation on the planet. When a typical leaf starts absorbing light from the sun, it actually ends up absorbing most of the optical light, including all of the colors of the rainbow, and some of the higher frequencies, such as ultraviolet light, either goes through the leaf or gets to interact with some of the structures, potentially damaging them. But the infrared light surprisingly gets reflected by the structures inside the leaf. And because of this, if you were to look at a typical tree or really any vegetation in the infrared light, you would see this extremely bright, extremely oversaturated object, which is exceptionally easy to see from outer space as well. All of the trees and all of the vegetation basically create this very interesting reflective infrared and also very saturated picture that is visible from a very far away distance. And so naturally, if we were to see something similar coming from another planet, this unusual reflectivity and unusual appearance of a red edge on another planet, the only natural explanation here is that something is creating similar structures to a typical leaf or a typical tree on another planet. But in case of red dwarf planets, we would expect this red
Дори и най-добрите планове могат да се объркат. Запушеният нос може не само да причини дискомфорт, но и да повлияе на емоционалното ви състояние. Носът се запушва при отток на лигавицата на носа и синусите.
Назалната промивка с хипертоничен разтвор на морска вода с концентрация на сол 2,6%,
която е по-висока от физиологичната, е натурално и ефективно средство за облегчаване на запушения нос. По-високата концентрация на сол извлича излишния секрет от лигавицата на носа, като по този начин намалява оттока и запушването. Промиването на носа също така активно почиства носните канали. В клинично проучване с 71 пациенти с запушен нос в резултат на различни причини, приблизително 77% докладват облегчение на запушения нос след употреба на хипертоничен разтвор. Приблизително 95% от пациентите намират поносимостта на разтвора за отлична или добра.
Quix Extra съдържа морска вода с концентрация на сол 2,6%, която е по-висока от естествените нива в организма.
Quix Extra съдържа напълно натурална морска вода, която се извлича от Атлантическия океан. Quix Extra има допълнителна съставка, която може да ви помогне да се справите с запушения нос. Quix Extra съдържа добавено евкалиптово масло, което създава усещане за чист и отпушен нос и улеснява дишането. Quix Extra е напълно натурален и не съдържа никакви консерванти. Не съдържа вредни вещества като бисфенол А, диоксин, латекс, сулфити или фталати. Quix Extra е създаден за лесна употреба и е снабден с валидиран антибактериален филтър и механизъм за автоматично затваряне. Няма риск от привикване и ограничение за продължителността на употреба. Може да се използва в комбинация с лекарства. В сезона на настинка и грип, Quix Extra облегчава запушения нос и има силен освежаващ ефект. От серията натурални продукти Quix.
red edge to be maybe slightly farther toward the infrared, maybe around 750, maybe even 800 nanometers. So basically slightly shifted to the right on this picture right here. And detecting something like this from, for example, Proxima Centauri, which can totally be done by James Webb Telescope in the next few years, would only mean that we've just found the possible signs of vast amounts of algae, trees, or some other strange life that's producing these effects and is also producing a lot of oxygen on these distant planets. And if by some luck we actually do find this on Proxima b, which is of course the nearest red dwarf planet to us, this means that this probably exists around the majority of planets out there, simply statistically speaking. If, however, we don't find anything, well, that's kind of expected right now. Statistically, we don't think we'll find anything here. But once again, this is only something we're going to know in the future once better telescopes are available to us and once we're able to observe these things in the infrared with much higher resolution and, of course, much better visibility. For now, we can only speculate and can possibly do experiments, such as of course the brilliant experiment I mentioned in this video, that you can read more about in the paper in the description below. Until we discover something else or until another really cool experiment, that's pretty much all I wanted to mention in this video. And because of this, I'm always fascinated to talk about this idea of astrobiology or life outside of planet Earth. Hello wonderful person, this is Anton, and today we're going to be talking about a discovery of a potential planet, possibly even an habitable zone, around one of the most exciting star systems next to us. The system currently known as Rigel-Kentaurus and Ptolemon, although that's not a name that a lot of us have heard of before. These two stars are more commonly known as Alpha Centauri, and that's probably the name that I'm going to be using for the rest of the video because the other two names are kind of confusing. Now, I'm sure you have heard of these stars before because that's basically the closest star system to us. The system of Alpha Centauri is technically actually connected to the neighbor Proxima Centauri, which can be barely made out right here where the circle is located. And together Alpha Centauri stars and Proxima Centauri form this somewhat interesting union, with Alpha Centauri A and Alpha Centauri B orbiting around one another every 79.9 years. With the average distance between these two stars being equivalent to the distance from the Sun to Uranus, roughly around 18 astronomical units. Whereas Proxima Centauri is much farther away at about 13,000 astronomical units, or about 0.2 light years away. And though mostly we've talked about Proxima Centauri so far because we've already confirmed two planets here, with one being in the habitable zone of the star itself, the scientists have always been more excited about trying to find something in the Alpha Centauri, because being the closest star system to us, it's also the closest star system with the stars very similar to our Sun, so-called solar analogs. The stars that are not too active, that don't really produce a lot of flares, and the stars that are generally mild enough to provide necessary conditions for long-term habitability of different planets. And here is a picture that sort of demonstrates how these stars compare. We have the Sun, we have the larger Alpha Centauri A, or the Rigel-Kentaurus as it's known, with a mass of about 1.1 masses of the Sun, and the luminosity that's about 50% higher than the Sun. Then we have the slightly smaller Ptolemon, with the size of about 0.9 masses of the Sun, and only about half the luminosity of the Sun. And lastly we have the Proxima Centauri, a typical M-type dwarf. And though Proxima Centauri is smaller, it's also a lot more active and produces a lot more extremely powerful flares, many of which have been detected in the last few years. And so naturally discovering something around the Sun-like stars is way more exciting, which is why in the last few years there have been a few announcements of possible planets. One of the first announcements was back in 2012, but within 3 years, several studies confirmed that it was nothing but the noise in the data. The planet most likely did not exist. Then, only a year later, the scientists observed an unusual passage of another possible planet. This was basically a shadow of a planet passing in front of a star, which did suggest that there could be an object orbiting one of the stars here. Now this hasn't of course been confirmed yet, but if confirmed this would be a really tight planet orbiting the Alpha Centauri B, also known as Ptolemon. And surprisingly this was an object with a total size of about 94 size of planet Earth, but the orbit here would be really close to the parent star. A single orbit here only takes about 20 days. This implies that this would be some sort of a lava world. This of course has never been confirmed since, and it's been over 7 or actually 8 years now, and this means that it could also have been a false detection. Many of these have happened in the past, so this wouldn't really be the first. But because this is such an exciting star system and because this is our neighbor, this has not stopped scientists in trying to discover more potential planets. And the most recent analysis has actually used something very different, something that has never really been used in such a way, and something that potentially discovered another planet, and this time maybe in the habitable zone of the star system. Now because this is our neighbor and because this star is pretty bright in the night skies, This actually creates a lot of problems for certain techniques in trying to detect planets around it. But there is one technique that we can definitely use on this star system, something that has also been used in the solar system quite a lot with our own sun. The method that's sometimes known as thermal chronography. It's essentially when you block the central object, in this case it's the sun, and then try to look for certain other objects, bright and possibly hot objects, in the vicinity. This is normally how we look at comets approaching the sun, and this is normally how we also discover certain objects, such as this one right here once again, that are both really close to the sun and also produce a lot of heat that's otherwise invisible because the sun is really bright and essentially overshadows their heat. And so if we block a star and then look at it in infrared imaging, for example, we can actually see heat generated around the star system. And because we know that planets and pretty much all objects do produce heat simply by reflecting or even through generation of heat on the inside, we can usually see them assuming that nothing blocks their heat or their emissions. And back in 2019, the famous Breakthrough Listen, or in this case one of the breakthrough initiatives known as Breakthrough Watch, began its collaboration with the European Southern Observatory and allowed the scientists to use a new tool known as VISOR, which stands for Very Large Telescope Infrared Imager. You can learn more about this particular tool in the article in the description below. And this allowed the scientists to now directly image some of the nearby stars, specifically stars within about 20 light years away from us, and to look at their infrared signatures. The main purpose, of course, being discovering new planets. Now, after about a year and a half, we now have one of the most exciting reports, a planet in the habitable zone from the closest star system to us. The planet that's visible in this image right here as this relatively large heat spot in the image produced by the VISOR tool. Now remember, this is still a preliminary discovery, but if this is confirmed and if this is indeed a planet orbiting in the star system, this would be a planet similar in mass to Neptune and would actually be right in the middle of the habitable zone, meaning that it would have conditions necessary for liquid water to exist. But it's also important to note here that a lot of other artifacts were discovered in these images, some which you can see in the image where the arrows are pointing, which obviously suggests that this is not a conclusive result just yet, and there could be a lot of interpretations to what it is that we're looking at here. Specifically, the spot that's referred to as C1 or Candidate 1 could also be cosmic dust, or really hot cosmic dust. It can also be some sort of reflection based on something else in the background. Or for all we know, it could also be a distant object just in the right location where the scientists were looking at. In other words, it doesn't actually confirm yet that this is a planet, but there is a way to confirm this. If we look at the star again in the next few days or possibly the next few months, and if we discover that this object shifted a little bit and is definitely orbiting something, we know for a fact that this is probably a planet. Because so far this is actually only based on 100 hours of observations. We'll need to do a lot more observations possibly in the next few months to see if this is really there. But also based on the amount of heat detected coming from this object, it most likely is not some sort of a terrestrial planet, and instead is more likely to be some sort of a gas planet, possibly even a gas giant. Although if it is some sort of a massive planet, it's more likely we would have found it a long time ago, because normally we can see these massive objects because of their effects on the star. They normally shift the star's motion across the night skies quite a lot. Because we haven't seen anything like this from Alpha Centauri, this planet is probably a lot less massive. But it still doesn't mean that it's a terrestrial planet. Because as of now, it does seem like the planet is reflecting a lot of the heat from the star, which of course suggests that it's probably larger than planet Earth and seems to be emitting a lot of heat as well. But more importantly, this is a huge milestone for the project itself. It only began operating a year and a half ago, and it's already collected a lot of useful data and has potentially discovered a habitable planet in a nearby star system. And of course, if confirmed, this would be one of the most exciting discoveries of the last few years. Which of course would also make the Alpha Centauri and the Proxima Centauri systems as essentially some of the most interesting systems in the vicinity. It would mean that both of them contain planets in the habitable zone, which at least statistically speaking would mean that pretty much most of the stars out there would have something in their habitable zones as well. But it's also important to remember that we've always wanted to find planets around binary systems, mostly because we want to learn and we want to understand how these planets survive for billions of years. It's generally really hard for stable orbits to form in binary systems, and for example for both stars here, the stable orbits are only within about 2.8 astronomical units, with the habitable zone for the smaller star being within 1.3 astronomical units, for the larger star almost reaching that limit at 2.2 astronomical units. This of course implies that if this particular planet exists in the star system, it's basically sort of already at the limit of where a stable orbit can form in the star system. If it's a little bit farther away, or if its orbit is eccentric, it does have a high chance of suddenly getting kicked out of the star system and basically becoming a rogue planet or colliding with the stars. And so once again, if this particular planet is confirmed and if it truly exists out there, this would be one of the most exciting and possibly one of the luckiest discoveries we've made in the last decade. A very strange, a very unusual, and a very peculiar object that really shouldn't actually even exist, but seems to exist nevertheless. But it will take a few months to confirm all of this, and possibly even longer. So for now, we don't really know if it's truly there, or if it's some warm dust, or possibly some other reflection coming from the star that was maybe formed by some sort of a cometary tail or some other activity, not so different of course from what we're seeing right here when the comet passes really close to the sun itself. So definitely exciting, but we just have to wait and see what happens with this. Hello wonderful person, this is Anton, and today we're going to be talking about this really exciting planet that was discovered back in 2015 that also seems to be the only planet we know of that lost its original atmosphere and now has acquired its second atmosphere. And this planet, known as Gliese 1132b, is actually one of two objects in this particular star system, both being extremely interesting. But let's actually talk a little bit more about this because it's a pretty exciting discovery. So first of all, this planet, as I mentioned, was discovered around 6 years ago. And even back then, the scientists became really excited because of the location of the planet and also because of the star and the distance to the star. This is about 40 light years away from us, so it's close enough for us to actually be able to study its atmosphere and a lot of other features. Also, the way that this planet moves and crosses the star while producing the shadow allows us to produce very detailed observations of what's inside the planet's atmosphere. When the planet was discovered, the scientists were convinced we're going to be able to see the atmosphere, to know exactly what the atmosphere is made out of, and even be able to tell the color of the night sky, or even be able to tell the color of sunsets on this particular planet. Mostly because, compared to our own solar system, this is actually a red dwarf star, so it's about 1/5 of the size of the sun, and on top of this, the planet itself is much closer to the star as well. A single orbit here only takes about 1.6 days. So in some sense this is a typical red dwarf system, but it's just perfectly located for us to study the atmosphere and to really learn a lot about this planet. But by looking at this planet, and of course by looking at the star for a long time, and also by doing a lot of other analysis, the scientists now estimate that the original atmosphere of this planet was most likely essentially hydrogen, kind of similar to what we have in planets like Saturn and Jupiter, which of course means that the original GJ1132b was probably a mini Neptune. Or in other words, it wasn't actually a terrestrial planet like you see right here, but it was probably more of some sort of a gas giant-like planet, although not really a gas giant, a mini Neptune. But with time, because of the proximity to the star, all of this heat started to evaporate the atmosphere, and all of the atmosphere was initially lost. Now, this is a concept we refer to as a Chtonian planet, a planet that evaporated and only a crust and the terrestrial core was left behind. This is actually something that the scientists believed for a pretty long time. All of the observations suggested that, but some of the recent observations, by looking at this location again, started to discover certain other elements present in the atmosphere of the planet, specifically things like methane and hydrogen cyanide, along with some parts of molecular hydrogen as well. And what this detection suggested is the fact that the planet must have created a second atmosphere after the first one was destroyed. Moreover, it seems to be able to recreate this atmosphere as more and more of it is lost. So some of this hydrogen that's still present there is still being lost to the rest of the star system. But the majority of new molecules formed that produce the atmosphere seem to be coming from within the planet itself, most likely either as a result of massive volcanism on the planet, or more likely through various seeping cracks around the planet where the gas just kind of leaks out through these various cracks formed on the planet, probably because of all of the tidal stress that the planet experiences as it orbits the star. With all of this hydrogen cyanide and methane very likely forming as a result of various gases mixing within the mantle of the planet, with hydrogen cyanide, for example, containing nitrogen, which is a very common gas present on planets like Earth and Mars, and both methane and hydrogen cyanide also containing hydrogen that was present on the planet initially. And though this planet is still pretty close to the star and is still experiencing the same amount of radiation and is thus losing some atmosphere even now, it probably reached some sort of a balance by now where the amount of hydrogen lost to the star system is sort of replenished through the emissions of all of this gas coming from within the planet itself. But the surprising calculations from the study also suggest that the atmospheric pressure here is extremely similar to the pressure of Earth. Basically, the amount of gas here is roughly around 1 atmospheric pressure, which means that it's kind of similar to Earth in some sense. So these calculations actually suggest that the atmospheric pressure here is roughly around 1 atmosphere. But unlike Earth, the gases here are very different. As a matter of fact, here's the illustration presents by one of the artists. It's probably more a Venus-like world. The atmosphere is very hazy, it's also obviously somewhat toxic, and to some extent, somewhat resembles early Earth, more so than really anything else we have in the solar system today. Earth back in the days also was a hydrogen-dominated planet, with a lot of methane, carbon monoxide, and a lot of other components present in the atmosphere, making it somewhat toxic as well. But eventually, with time, Earth transformed into something a little bit more beautiful and turned into a water world, as I've discussed in one of the previous videos, somewhere right there. So anyway, back to the planet. Also, unlike Earth, this object is probably extremely hot, at least on the side of the planet that's facing the star. This planet is tidally locked, like a lot of other planets orbiting red dwarfs. But the question here is, of course, what happens in the twilight area, specifically area right here between the dark and the bright side of the planet, or what actually happens on the dark side of this planet. This is actually something that a lot of scientists would now love to know. And remember, because of the dark side here, the temperatures are going to be more bearable. Also, we have this very thick atmosphere with certain compounds that can technically be used by bacteria. Now, I was actually wondering what sort of temperatures could be produced on this planet, especially on the dark side, so I tried to create this simulation of this planet using Universe Sandbox. And more specifically, I really wanted to look at this temperature distribution graph that usually shows you what a typical tidally locked planet would have on its surface. So all of this red stuff here, that's super hot. This is like hundreds of degrees Kelvin, basically even hotter than Venus. And pretty much everything along the equator, assuming that the planet spins in the same direction as planet
За да победиш, трябва да си силен. Трябва да си бърз и да прилагаш правилния инструмент. Top Master Professional, лимитирана серия, Тервел Пулев.
Earth is still pretty hot, just over 200 degrees Celsius. But on the polar side, especially in certain locations, the temperature actually becomes somewhat bearable. As a matter of fact, right here, that's the average temperature of planet Earth. So the way that things are looking right now, what we have here is a really exciting planet. Even though it's tidally locked, that could actually provide it with certain locations on the surface, depending of course on how the atmosphere is distributed across the planet, which would allow it to have temperatures somewhat similar to planet Earth, but with those locations most likely being in complete darkness. So hypothetically, if there is any bacterial life here, it would most likely have to use some other power source to survive, very likely chemical source. But let's not go into this whole alien life discussion yet, because we don't really know what's happening on this planet. What we do know, however, is that this planet most likely undergoes a lot of tidal stress and a lot of tidal heating, which is a process that usually happens to certain moons or even certain planets when a more massive object starts to kind of stretch them apart. A very good example here would be the moon known as Io orbiting Jupiter, which is sort of being pulled at by Jupiter, but also by its partners Europa, Ganymede, and Callisto. And because of this, the moon gets stretched into an egg and then returns back into a spherical shape. In contrast, our own moon is always an egg. Because of this, Io is the most volcanically active object in the solar system, and all of the stuff from inside Io comes out and creates 4 different atmospheric effects and also interacts with Jupiter as well. So something similar very likely happens around this planet as well. And the reason for this is that it has a partner that orbits not so far away from this particular planet, the object known as GJ132c, and possibly even another partner even farther away. At the same time, a lot of these tidal effects are increased dramatically because of the orbit of the planet. The planet orbits with a slight eccentricity. And because of this planet very likely has extremely thin crust. So thin as a matter of fact that it probably has no hills, no mountains, basically extremely flat terrain. And all of this of course suggests that this is an extremely volcanically active planet. Or at least on one side. We don't really know what happens on the other side. For all we know, one of the sides here is extremely active and very hot, so sort of like this illustration I showed you previously, but the other side, the one always facing the darkness, has a somewhat more comfortable climate. That's of course not something we can improve or show just yet, but it's something we can technically simulate using some of the computer simulations we have today, like NASA's rocket. I'm sure someone will come up with a study in some near future. Either way though, so far this is one of the most exciting discoveries of exoplanets out there, and definitely a pretty cool planet simply because of the fact that it has very similar atmospheric pressure to Earth and the other object in the solar system known as Titan. So now that means that we have 3 objects with pressures where technically you can kind of stand and not get crushed by anything or lose consciousness because there's not enough pressure. Although on this particular planet, standing here without some sort of a gas mask, the hydrogen cyanide is probably going to get you pretty quick. Oh, and the other exciting fact that I forgot to mention is that the planet is also relatively similar age to planet Earth, about 4.5 billion years old. So, very exciting discovery, very exciting star system, and for all we know, we might also find something super exciting around its partner, which is actually also a potentially rocky world, slightly larger than planet Earth. And also slightly cooler in temperature as well because its orbit is around 8 days around the star. And in this particular simulation, this is what it sort of looks like. It actually resembles Earth to a very eerie extent. Hello wonderful person, this is Anton, and today we're going to be talking about new analysis and new discoveries coming from one of the more exciting systems near us, the star system known as Tau Ceti. And though we talked about this star system a few years ago, it's actually worth talking about it again because new discoveries suggest that it actually has some really interesting planets in it. Specifically, it seems to possess 8 different planets, with at least one of them potentially being in the habitable zone. But let's discuss this in a little bit more detail, starting with the star itself. The lonely star, approximately 12 light years away from us. If you remember the distances to other stars, this means that this is actually one of the closest stars to us. As a matter of fact, this is the second closest G-type star, and G-type stars are the ones we are particularly interested in, simply because this is what you would call a solar analog. It's a star extremely similar to our Sun, at least in terms of the amount of energy it produces. Here's for example how it compares to our own Sun, with the Sun being on the left. So it is a little bit smaller, it's about 78% of the total mass of the Sun. It also seems to produce about half of the luminosity of our Sun, but in terms of the age, it's relatively similar. It's about 5.8 billion years old, although it does seem to only contain about 1/3 of metallicity of our own Sun, which of course implies that it's mostly made out of hydrogen and helium and a lot less of other materials, which of course could also influence the composition of planets in the orbit of this star. And interestingly, the star is also slowly approaching the solar system, so in approximately 43,000 years from now, it's going to be at its closest approach just a little bit over 10 light years away from us. And because of all of these strange similarities to our Sun, like for example the fact that it's a lonely star, it doesn't have any partners like Alpha Centauri does, and also because originally we've discovered planets here a few years ago, this star has always been sort of the primary source of investigation, speculation, and interest when it comes to search for extraterrestrial intelligence, and of course potential colonization of any kind of a star system. As a matter of fact, several different projects looking for extraterrestrial intelligence focused on this star in the past, one being this one right here, Project Phoenix, and one being the older project known as Project Ozma. But of course, nothing has been discovered so far, and at the moment, it doesn't seem like anyone is trying to communicate with us or is sending any artificial signals from the star system. But because the star is so stable and also so similar to the Sun, and also because back in 2012 we've discovered several planets here, with originally 4 different planets assumed to be in orbit of this star system, Tau Ceti has been actually growing in popularity and has now become one of the most interesting stars in the vicinity, with some of the recent papers suggesting that this particular star system contains 8 different planets, kind of similar to solar system in that sense. And interestingly, at least one of these suggested planets seems to be in the habitable zone of Tau Ceti. And so it's really interesting to kind of explore this system once again, just to find out what we've learned about it in the last few years. Now, first of all, these original 4 planets discovered back in December of 2012 were actually discovered by looking at the slight wobbles of the star itself. They weren't discovered by looking at the shadows like we usually do, and so in this case by investigating slight changes in the velocity of the star. With the velocity changes of about 11 meters per second, the scientists were able to observe the original 4 planets, with all 4 planets being what you would call a super Earth or a mini Neptune. A lot more massive than planet Earth, but not as massive as, for example, Saturn and Jupiter. But as the scientists kept studying the data coming from this particular star, additional hints of other planets started to appear as well, including what seems to be a Jupiter-like planet at a slightly farther away distance of about 3 to maybe 20 astronomical units, and also several
Physicists have been hunting for one particle longer than perhaps any other. It's not the tachyon or some supersymmetric particle, it's the magnetic monopole. And of all the fantastical beasts of particle physics, this is perhaps the most likely to actually exist. So, where are they all? Most likely to actually exist. So, where are they all? Let's try an experiment. Take a metal bar and force all the electrons to one end. The electric field of the bar now looks like this. That's a dipole field. Now, cut the bar in half and you get a pair of electric charges, one negative and one positive, both of which have electric fields that radiate straight out. Now, take a metal bar and instead magnetize it. You get a dipole magnetic field that's very similar to the dipole electric field. So if we cut this bar in half, surely we get a pair of dipole electric. Magnetize it. You get a dipole magnetic field that's very similar to the dipole electric field. So if we cut this bar in half, surely we get a pair of magnetic charges similar to our electric charges, right? Wrong. The ends of the split magnet still have north and south poles and still generate a dipole field. And according to classical electromagnetism, it doesn't matter how many times you slice it, you'll never get isolated magnetic charges, what we call magnetic monopoles. This magnet slicing experiment was first performed by French scholar and Beauxbaton's Academy professor Petrus Peregrinus de Marancourt way back in 1269. That was before we knew what caused the magnetism in magnets. These days we know where magnetism comes from, and we're not so surprised that a halved magnet just makes two smaller magnets. In a ferromagnet, the field is the sum of the countless tiny aligned dipole fields of electrons in the magnet's atoms. The other popular way to make a dipole fields of electrons in the magnet's atoms. The other popular way to make a dipole magnetic field is the electromagnet, where we push electrons around in a circle. In both cases, electron spins or a circular electric current, there's a sense of electric charge in motion. And according to classical electrodynamics, moving electric charge is the source of the magnetic field. If that's true then, why should we even expect there to be isolated magnetic charges, magnetic monopoles? Well, according to the classical theory, we shouldn't. The non-existence of magnetic monopoles is codified in the mathematics of electrodynamics, in particular Gauss's law for magnetism, one of the four Maxwell's equations. It states that the divergence of a magnetic field is zero. The divergence is just this mathy term for the amount that a field points inward towards a sink or outwards from a source. Zero divergence means no source and no sink. Magnetic field lines can form loops or head out towards infinity, but they never end. According to this law, there are no magnetic monopoles. On the other hand, Gauss's law for electric fields tells us that the divergence of the electric field is not zero. It's equal to the electric charge density. That charge density is where the electric field lines can end, and they form their source or their sink, so there are such things as isolated electric charges. Let's take a quick gander at Maxwell's equations. This is them without any charges, electric or magnetic. Zero divergence means just this mathy term for the amount that a field points inward towards a sink or outwards from a source. Zero divergence means no source and no sink. Magnetic field lines can form loops or head out towards infinity, but they never end. According to this law, there are no magnetic monopoles. On the other hand, Gauss's law for electric fields tells us that the divergence of the electric field is not zero. It's equal to the electric charge density. That charge density is where the electric field lines can end, and they form their source or their sink, so there are such things as isolated electric charges. Let's take a quick gander at Maxwell's equations. This is them without any charges, electric or magnetic. E is the electric field and B is the magnetic field. There's a near perfect symmetry between electricity and magnetism, which only gets screwed up when you put in the electric charge, here in the form of charge density and current density. You could also have symmetry between these equations if there was such a thing as magnetic charge. If you add magnetic charges to these equations, then you get a magnetic force that looks exactly like the electrostatic force. The physicist Murray Gell-Mann said that everything not forbidden is compulsory, meaning that if the math of our physical theory allows it, then it exists in nature. Now, there's nothing in Maxwell's equations that really says that magnetic monopoles can't exist, except for the fact that James Clerk Maxwell set the magnetic charge to 0 because he didn't believe that it existed. But in principle, it could exist, and so could magnetic monopoles, at least according to classical theory. But what about quantum mechanics? When quantum theory first appeared, it quickly revolutionized our understanding of electromagnetism by explaining it in terms of quantum fields rather than charges and forces. Now, we talked previously about how electromagnetism arose automatically from requiring that the equations of quantum mechanics had a particular symmetry. The measurements they predict are unaltered by changes in one simple property, the phase of the wave function. Electromagnetism pops into the equations as soon as we require this. But in that version of electromagnetism, the electric and magnetic fields are very different from each other and not at all interchangeable as they are in Maxwell's equations. In particular, the magnetic field emerging from the quantum theory must have zero divergence. Its field lines can never end, so it can't have its own charge, unlike the electric field. So perhaps here we have our reason for the apparent non-existence of magnetic monopoles. Quantum mechanics, as the saying goes, forbids it. Well, not so fast. Don't underestimate the power of the obsessed physicist. The great Paul Dirac had a habit of discovering particles just by staring at the math. In 1928, he predicted the existence of antimatter this way, as we've discussed in a previous episode, but then, in 1931, just before his antimatter thing was verified, Dirac made another prediction of the existence of magnetic monopoles. His argument goes something like this. If you start with a dipole magnetic field, you can approximate a monopole by moving the ends far enough apart and somehow vanishing the connecting field lines. And there is a way to do that. If you build a solenoid, just a coil carrying an electric current, you get a dipole field whose connecting field lines are constrained within the coil. So make the width of the coil much smaller than the length, and it looks like two isolated magnetic charges. This construction is called the Dirac string. And Dirac's argument is that if the string part of the Dirac string is fundamentally undetectable, then magnetic monopoles can exist. The second part of the argument is under what conditions that string is undetectable. So magnetic fields affect charged particles. In quantum mechanics, this works by shifting the phase of the particle's wave function. Imagine a charged particle passing by a Dirac string. To plot that trajectory, you add up all the possible paths of the electron, including paths to the left and the right of the string. Presence of the string with its magnetic fields should introduce different phase shifts depending on which side of the string the electron passes. And that would actually have a noticeable effect on the path of the electron. In other words, the string would be detectable. But there's one scenario where the string can never be detected. The amount of this phase shift is proportional to the electric charge. For the right value of that charge, the phase shift induced between the different sides of the string is exactly one wave cycle, which means no observable difference. So for the Dirac string to be undetectable, then electric charge can only exist in integer multiples of that basic charge. This is a very loose form of the argument, and you can get to this in different ways, but the upshot is that the string connecting monopoles is fundamentally unobservable, and Dirac argued that this makes it a mathematical figment, kind of like virtual particles, and reality should only be assigned to the monopoles themselves. On the one hand, this was taken as a prediction of the quantization of electric charge. Electric charge has to be discrete if there's even a single magnetic monopole in the entire universe. And of course we know that electric charge really is quantized. It can only be integer multiples of the charge of the electron, or maybe of quarks, a third of the electron charge. But instead of taking this as a prediction of charge quantization, you can also flip it. Magnetic monopoles are possible if electric charge is quantized. Charge turns out to be quantized, so quantum mechanics doesn't actually forbid monopoles. Let's fast forward 40 more years. In the early 70s, physicists had managed to explain the weak nuclear force and unify it with electromagnetism. We talked about that before, about how the breaking of the symmetry of the Higgs field separated the weak and electromagnetic forces. With that squared away, physicists were working to bring the strong nuclear force into the fold with so-called grand unified theories. These involve slightly more complicated symmetry breakings. Well, it turns out that magnetic monopoles are inevitable in all of these guts with electromagnetism. We talked about that before, about how the breaking of the symmetry of the Higgs field separated the weak and electromagnetic forces. With that squared away, physicists were working to bring the strong nuclear force into the fold with so-called grand unified theories. These involve slightly more complicated symmetry breakings. Well, it turns out that magnetic monopoles are inevitable in all of these guts. Let me try to give you a sense of why. And we have to talk a bit about the Higgs field to do this. Now, we've done a couple of Higgs episodes before if you want to get all the nitty-gritty, but in electroweak theory, the Higgs field is a scalar field. It takes on a numerical value everywhere in the universe, but with no direction. It's not a vector. In fact, it really takes on two complex values everywhere, and the interplay between those two degrees of freedom gives the Higgs its power. In the simplest grand unified theory, the Higgs field has 3 degrees of freedom instead of 2. That means that the field can sort of act like a vector, even though it really isn't one. It can have a little internal arrow that points at a particular direction, not pointing in physical space, but in the space of those 3 degrees of freedom. Now, the laws of physics shouldn't care about the relative internal values of the Higgs field. What matters is the absolute length of that internal vector, not the direction it's pointing. There should be no noticeable effect even if the direction of the Higgs field changes smoothly across space. Except in one very special case. If the direction of the Higgs field varies smoothly from one point to the next, it can still have these sorts of knots, places where the field arrows all point away from that point in what we call a hedgehog configuration. These are topological discontinuities, points that can't be removed by a smooth deformation of space. And it turns out that these knots in the Higgs field in gut theories behave as massive particles with magnetic charge, magnetic monopoles. The hedgehog solution was figured out in 1974, simultaneously by Gerard 't Hooft and Alexander Polyakov. It turns out that gut theories generically predict these magnetic monopoles and that they should be A, very massive, and B, they should form spontaneously in extremely high energy environments, like in the very early universe. The fact that magnetic monopoles should exist in these theories was both exciting and problematic. Guts predict that monopoles should be produced in enormous numbers in the very early universe, as abundantly as protons and electrons. So where are they all? They should also be very massive, quadrillions of times the mass of the proton, and so should have quickly recollapsed the universe. This conflict with reality might have ruled out both monopoles and the grand unified theories that predicted them, except that both of these ideas are potentially saved by yet another speculative idea, cosmic inflation. Many physicists think that a period of prodigious exponential growth kicked off the expansion of our universe. This should have happened after the production of magnetic monopoles, and so should have thrown these things so far apart that there may be very few remaining in our another speculative idea, cosmic inflation. Many physicists think that a period of prodigious exponential growth kicked off the expansion of our universe. This should have happened after the production of magnetic monopoles, and so should have thrown these things so far apart that there may be very few remaining in our entire observation. observable. And these bit of prodigious exponential growth kicked off the expansion of our universe. This should have happened after the production of magnetic monopoles, and so should have thrown these things so far apart that there may be very few remaining in our entire observable universe. Now, that would be a bummer for our hopes of detecting these things, but that hasn't stopped physicists from trying. There are various approaches. If you have one of these magnetic monopoles in your lab, it wouldn't be too hard to spot. For example, a monopole would excite an electric current if it passed through a conducting coil. Back in 1982, the physicist Blas Cabrera Navarro set up a superconducting coil in his Stanford lab and managed to detect what looked like a monopole with the same charge predicted by Paul Dirac. But no one ever saw such a thing ever again, and that includes the Large Hadron Collider, where a couple of different experiments have failed to spot monopoles created in the collider. That's not so surprising given that the LHC reaches energies about 100 billion times lower than what's needed to produce the monopoles predicted by grand unified theories. People also look for magnetic monopoles coming from space, typically using cosmic ray observatories or contributing to the Earth's magnetic field, and in a number of other ways. But again, no convincing evidence as of yet. We have been hunting for magnetic monopoles for longer than just about any other particle. Their discovery would mean cracking open the grand unified theories and revealing mysteries far beyond. And so many of us remain obsessed with this elusive beast and convinced of its inevitability according to the symmetries of space-time. If you've joined us on Patreon, I can't emphasize how helpful your support is in keeping this show going. You don't have to do it, you could keep watching for free anyway, but that makes it all the more awesome of you. Today, I want to give a huge shout out to our Big Bang supporter, Kyle Bullock. Kyle, we are taught by Paul Dirac that if there's even a single magnetic monopole in the entire universe, then electric charge must be quantized. We don't know where that single magnetic monopole would be, but it's rare and special, and so we decided to name it after you. So now Kyle, the magnetic monopole Kyle, is doubly important. Sure, it ensures the quantization of all charge, but it also serves as a testament to the generosity of Kyle the human. Kyle, you have our thanks, and now you also have a monopole. Last week we talked about how quantum spin leads to the universe as we know it, for example, all the structure of solids via the Pauli exclusion principle. 4F Magnet points out a potentially misleading point in that episode. We represented very distinctly separated electron energy levels in our explanation of how fermions can't occupy identical quantum states. 4F Magnet notes that energy levels in atoms can actually hold 2 electrons, not 1, because it's possible to have 2 electrons at the same energy, but different quantum states by allowing for opposite spin orientations. And that's a fair call. If I was being more careful, I would have said that we were trying to represent separate quantum states, not the